Hi everyone, I am Mayank and welcome to this amazing artificial intelligence crash course by Simplilearn. Before we begin, if you enjoy watching these type of videos and find them interesting, subscribe to our YouTube channel as we bring you the best videos daily. Also hit the bell icon to never miss any update from Simplilearn. So let's get started. We will be briefing you with a detailed introduction to artificial intelligence that covers the data sources and the types of AI. After that, we will see the AI engineer roadmap, and after that, we will see the top skills required to become an AI engineer. Up ahead, we will walk you through some amazing concepts like supervised versus unsupervised versus reinforcement learning. Moving forward, we will see linear regression and many more. After that, we will see the top 10 AI projects ideas. After that, we will see the top 10 AI companies, and at the last, we will see the career opportunities in AI. Moving forward, we will cover amazing project in this crash course like movie recommendation systems. Speaking of interviews, we have covered you along with the most frequently asked artificial intelligence interview question to help you correct the toughest interviews. Before we move on to the what AI is, if you are an aspiring AI ML engineer, then there is no better time to train yourself in the exciting field of AI. If you are looking for a course that covers everything from fundamental to advanced techniques, then accelerate your career in AI and ML with our comprehensive postgraduate program in AI and machine learning. Boost your careers with this course delivered in collaboration with Purdue University and IBM. Learn in-demand skills such as machine learning, deep learning, NLP, computer vision, reinforcement learning, generative AI, prompt engineering, ChatGPT, and many more. You will receive a prestigious certificate and Ask Me Anything session by IBM. With 5 capstone in different domain using real dataset, you will gain practical experience. Master classes by Purdue faculty and IBM expert ensure top-notch education. Simplilearn's Job Assist help you get noticed by leading companies. These programs cover statistics, Python, supervised and unsupervised learning, NLP, neural network, computer vision, GANs, Keras, TensorFlow, and many more skills. Admission to this postgraduate program in AI/ML course requires 2+ years of work experience preferred, a bachelor degree with an average 50% or higher marks, basic understanding of programming concepts and mathematics. So why wait? Enroll now and unlock exciting AI/ML opportunities. The link is in the description box below. So without any further ado, over to our training expert.
It's a weekend, and John decided to watch the latest movie recommended by Netflix at his friend's place. Before heading out, he asked Siri about the weather and realized it would rain. So he decided to take his Tesla for the long journey and switch to autopilot on the highway. After coming home from the eventful day, he started wondering how technology has made his life easy. He did some research on the internet and found out that Netflix, Siri, and Tesla are all using AI. So, what is AI? AI, or artificial intelligence, is nothing but making computers-based machines think and act like humans. Artificial intelligence is not a new term. John McCarthy, a computer scientist, coined the term artificial intelligence back in 1956, but it took time to evolve as it demanded heavy computing power. Artificial intelligence is not confined to just movie recommendations and virtual assistants. Broadly classifying, there are 3 types of AI. Artificial narrow intelligence, also called weak AI, is the stage where machines can perform a specific task. Netflix, Siri, chatbots, facial recommendation systems are all examples of artificial narrow intelligence. Next up, we have artificial general intelligence, referred to as an intelligent agent's capacity to comprehend or pick up any intellectual skill that a human can. We are halfway into successfully implementing this phase. IBM's Watson supercomputer and GPT-3 fall under this category. And lastly, artificial superintelligence. It is the stage where machines surpass human intelligence. You might have seen this in movies and imagined how the world would be if machines occupied it. Fascinated by this, John did more research and found out that machine learning, deep learning, and natural language processing are all connected with artificial intelligence. Machine learning, a subset of AI, is the process of automating and enhancing how computers learn from their experiences without human help. Machine learning can be used in email spam detection, medical diagnosis, etc. Deep learning can be considered a subset of machine learning. It is a field that is based on learning and improving on its own by examining computer algorithms. While machine learning uses simpler concepts, deep learning works with artificial neural networks, which are designed to imitate the human brain. This technology can be applied in face recognition, speech recognition, and many more applications. Natural language processing, popularly known as NLP, can be defined as the ability of machines to learn human language and translate it. Chatbots fall under this category. Artificial intelligence is advancing in every crucial field like healthcare, education, robotics, banking, e-commerce, and the list goes on. Like in healthcare, AI is used to identify diseases, helping healthcare service providers and their patients make better treatment and lifestyle decisions. Coming to the education sector, AI is helping teachers automate grading, organizing, and facilitating parent-guardian conversations. In robotics, AI-powered robots employ real-time updates to detect obstructions in their path and instantaneously design their routes. Artificial intelligence provides advanced data analytics that is transforming banking by reducing fraud and enhancing compliance. With this growing demand for AI, more and more industries are looking for AI engineers who can help them develop intelligent systems and offer them lucrative salaries going north of $120,000. The future of AI looks promising, with the AI market expected to reach $190 billion by 2025.
Artificial intelligence is reshaping industries and transforming the way we live and work. It encompasses a wide range of technologies including machine learning, deep learning, natural language processing, computer vision, and many more. With its ability to analyze vast amount of data and make intelligent decisions, AI has become a game changer across various domains. Hi everyone, welcome to Simplilearn's YouTube channel. This AI roadmap guides you in navigating the path towards building a successful career in artificial intelligence. The ultimate goal of artificial intelligence is to create intelligent machines that can perform complex tasks, exhibit human-like intelligence, and contribute positivity to society. AI presents exciting career opportunity in various industries and sectors. Roles like AI engineer, data scientist, NLP engineers, computer vision engineers, AI research scientists, robotic engineers, and many more offer exciting prospects for working with cutting-edge technologies and making an impact through artificial intelligence innovation. According to Glassdoor, the average reported salary of an AI engineer in the United States is around $105,000 per year. However, in India, it is 10 lakh per annum. Leading companies worldwide are fully aware of the immense value of AI and are actively pursuing skilled AI engineers to contribute to their research, development, and implementations of AI technology. Among these top companies are Google, Microsoft, Amazon, Goldman Sachs, Apple, and JP Morgan Chase. Therefore, top companies hiring AI engineer provide excellent opportunity for aspiring professionals. On that note, elevate your career with our AI and ML course developed in partnership with Purdue University and IBM. Gain expertise in high-demand skills such as machine learning, deep learning, NLP, computer vision, reinforcement learning, ChatGPT, generative AI, explainable AI, and more. Unleash your potential and unlock exciting opportunity in the world of AI and ML. This course covers tools like Python, TensorFlow, Keras, ChatGPT, OpenAI Gem, Matplotlib, and many more. So hurry up and find the course link in the description box for more details. Our learners have experienced huge success in their careers. Listen to their experience. Find the Simplilearn course review link in the description box. Without any further delay, let's dive into the topic now. If you desire to become an AI engineer, here are the steps you can follow to achieve your goal. Firstly, obtain a strong foundation in mathematics and programming. Gain a strong foundation in creating mathematical concepts like linear algebra, calculus, and probability theory. In addition to that, it is crucial to acquire mastery of programming languages like Python, commonly used in AI, and become proficient in coding. Then, earn a degree in a relevant field. That means, earn a bachelor's or master's degree in computer science, data science, AI, or a related field to gain a comprehensive understanding of AI principles and techniques. Next, gain knowledge in machine learning and deep learning. To become an AI engineer, develop familiarity with ML algorithms, neural networks, and deep learning frameworks, example TensorFlow, PyTorch, to train and optimize models using real-world dataset. Followed by that, work on practical projects. Gain hands-on experience and showcase your skills by working on AI projects. Moreover, build a portfolio of projects demonstrating your ability to solve AI problems, impressing potential employers. Then, stay updated with the latest advancements. Stay updated with the latest trends and research in AI, a rapidly evolving field, and expanding your knowledge by reading research papers, participating in online courses and workshops, and joining AI communities. Next, collaborate and network. Engage with AI communities, attend conferences, participate in online forums to connect with professionals in this field. Collaborating with others can enhance your learning experience and open new opportunities. Later, seek internships or entry-level positions. Gain practical experience through AI internships or entry-level roles in industry or research institutions. This provides valuable exposures and help develop your skills. Finally, continuously learn and adapt. In the rapidly evolving field of AI, stay updated on new developments, explore specialized areas, and embrace emerging technologies and tools to pursue a career as an AI engineer. Now that we have covered the essential steps to become an AI engineer, let's explore the necessary programming languages and algorithms for aspiring AI engineers. So, mastering programming languages like Python, R, Java, and C++ is vital for acquiring proficiency in AI. These languages enables you to construct and deploy models effectively. Additionally, it would help if you gain a thorough understanding of machine learning algorithms such as linear regressions, k-nearest neighbors, naive Bayes, and support vector machines. These languages and algorithms are fundamental tools in the field of AI. They will enable you to develop and implement effective artificial intelligence models.
Hello everyone and welcome to our video on skills required for an AI engineer. With the advent of artificial intelligence and its superior abilities to improve human life, the need and demand for expert AI professionals is at an all-time high. This expanding demand has led to a lot of people applying for AI jobs and upskilling themselves in the field of AI. But doing this is just like playing a game but not knowing its rules. For someone to become an AI professional and land a job like an AI engineer, they first have to understand the demand from this role and what skills are expected of an AI engineer. So if you are someone who wishes to become an AI engineer, or if you wish to upgrade your skills in AI and get promoted as an AI engineer, then make sure you watch this amazing video till the very end. In this video, we will be breaking down in complete detail each and every skill that you would need in order to crack an AI engineer job interview. But why should you consider a career in AI? AI is not just a passing trend. It's a seismic shift that is reshaping our world and creating new avenues for innovation and discovery. By embracing a career in AI, you become a part of a dynamic field that thrives on solving complex problems, pushing boundaries, and making a profound impact on society. The demand for AI professionals is skyrocketing across industries, from healthcare and finance to entertainment and transportation. Organizations are actively seeking talented individuals who can harness the power of AI to drive their business forward. But what skills does it take to become an AI engineer? How can you embark on the thrilling journey? We have answered to all the field of AI and becoming an AI engineer. Let's go through them real quick. First, establish a strong foundation in mathematics and programming. Start by gaining a solid understanding of critical concepts like linear algebra, calculus, and probability theory. Additionally, it is crucial to become proficient in programming language like Python, which is commonly used in AI, and develop coding skills. And the next one is pursue a degree in relevant field. Earn a bachelor or master degree in computer science, data science, or AI or related discipline to acquire comprehensive understanding of AI principles and techniques. Then, acquire knowledge in machine learning and deep learning. Familiarize yourself with ML algorithms, neural networks, and deep learning frameworks, that is TensorFlow and PyTorch, to train and optimize models using real-world datasets. Afterward, engage in practical projects. Gain hands-on experience and demonstrate your skills by working on AI projects. Building a portfolio of projects that showcase your ability to solve AI problems can make a strong impression on potential employers. And the fifth one is collaborate and network. Engage with communities, attend conferences, and participate in the online forums to connect with the professionals in the field. Collaborating with others can enhance your learning experience and open up new opportunities. And the sixth one is seek internship or entry-level positions. Gain practical experience through AI internship or entry-level roles in industries or research institutions. This will provide valuable exposure and help you further develop your skill. And at the last, continuously learning and adapt. In the fast-paced world of AI, it is crucial to stay updated on new developments, explore specialized areas, and embrace emerging technologies and tools. Continuous learning and adaptability are essential for pursuing a successful career as an AI engineer. So, now that you are familiar with the steps involved in the journey of AI engineer, let's have a look at the salary of an AI engineer. So, according to Glassdoor, the average reported salary of an AI engineer in the United States is $105,000 per year. However, in India, it is 10 lakh per annum. So, these figures are way better than the average salary figures of any job role. So, let's discuss the skills you need to become an AI engineer. You should have a strong background in data science and machine learning. Here is a breakdown of your skills. Number 1, strong programming abilities. They typically refers to expertise in one or more programming languages commonly used in data science and machine learning, such as Python and R. Proficiency in programming allows you to write efficient and scalable code for data analysis, modeling, and algorithm implementation. And the second one is knowledge of machine learning algorithms. This involves understanding and familiarity with a wide range of machine learning algorithms, including both supervised and unsupervised learning. You should be able to select and apply appropriate algorithm for a specific problem as well as evaluate and optimize their performance. And the third one is proficiency in statistics and mathematics. Sound knowledge of statistics and mathematics is fundamental for data analysis and machine learning. You should be comfortable with statistical concept, hypothesis testing, regression analysis, probability theory, linear algebra, and calculus. And the fourth one is familiarity with deep learning frameworks. Deep learning has gained significant popularity in recent years, and familiarity with deep learning frameworks like TensorFlow, PyTorch, or Keras is valuable. These frameworks provide tools and libraries for building, training, and deploying deep neural networks for tasks such as image recognition, natural language processing, and time series analysis. And the fifth one is experience with big data technologies. Dealing with large scale dataset requires knowledge of big data technologies such as Apache Hadoop or Apache Spark or distributed computing frameworks. Understanding how to process, store, and analyze data efficiently in distributed environment. And the sixth one is excellent problem solving and analytical skills. These skills enable you to break down complex problems, identify key factors, and develop effective solutions. You should be adept at critical thinking, troubleshooting, and debugging to handle real-world challenges in the data science and machine learning. Remember to stay updated with the latest advancement in the field and continue learning to stay at the forefront of data science and machine learning.
First, let's understand what really is artificial intelligence. Artificial intelligence is the science of building intelligent machines from vast volumes of data. This data can be structured, semi-structured, or unstructured in nature. AI systems learn from past experiences and perform human-like tasks. Artificial intelligence enhances the speed, precision, and effectiveness of human efforts. AI uses sophisticated algorithms and methods to build machines that can make decisions on their own. Deep learning and machine learning are the two subsets of artificial intelligence. So, you need both machine learning algorithms and deep learning networks to build intelligent systems. AI is now being widely used in almost every sector of business, such as transportation, healthcare, banking, retail, entertainment, and e-commerce. Now, let's look at the different types of artificial intelligence. So AI can be classified based on capabilities and functionalities. Under capabilities, there are three types of artificial intelligence. They are narrow AI, general AI, and super AI. Under functionalities, we have four types of artificial intelligence: reactive machine, limited memory, theory of mind, and self-awareness. Let's look at them one by one. First, we will look at the different types of artificial intelligence based on capabilities. So what is narrow AI? Narrow AI, also known as weak AI, focuses on one narrow task and cannot perform beyond its limitations. It aims at a single subset of cognitive abilities and advances in that spectrum. Applications of narrow AI are becoming increasingly common in our day-to-day lives as machine learning and deep learning methods continue to evolve. Apple's Siri is a simple example of a narrow AI that operates with a limited predefined range of functions. Siri often has challenges with tasks outside its range of abilities. IBM Watson supercomputer is another example of narrow AI which applies cognitive computing, machine learning, and natural language processing to process information and answer your questions. IBM Watson once outperformed human contestant Ken Jenkins to become the champion on the popular game show Jeopardy! Other examples of narrow AI include Google Translate, image recognition software, recommendation systems, spam filtering, and Google's page ranking algorithm. Next, we have General Artificial Intelligence or General AI. General AI, also known as Strong AI, has the ability to understand and learn any intellectual task that a human can. General Artificial Intelligence has received a $1 billion investment from Microsoft through OpenAI. It allows the machine to apply knowledge and skills in different contexts. AI researchers and scientists have not achieved strong AI so far. To succeed, they would need to find a way to make machines conscious, programming a full set of cognitive abilities. Fujitsu built the K computer, which is one of the fastest computers in the world. It is one of the most notable attempts at achieving strong AI. It took 40 minutes to simulate a single second of neural activity, so it is difficult to determine whether or not strong AI will be achieved in the near future. Tianhe 2 is a supercomputer created by China's National University of Defense Technology. It currently holds the record for CPS at 33.86 petaflops. Although it sounds exciting, the human brain is estimated to be capable of 1 exaflop. Now CPS means characters per second that a system can process. Third in the list of AI that is based on capabilities, we have Super AI. Super AI exceeds human intelligence and can perform any task better than a human. The concept of artificial superintelligence sees AI evolve to be so akin to human emotions and experiences that it doesn't just understand them, it evokes emotions, needs, beliefs, and desires of its own. Its existence is still hypothetical. Some of the key characteristics of Super AI include the ability to think, solve puzzles, make judgments, and decisions on its own. Now, if you have enjoyed watching this video so far, please make sure to subscribe to our YouTube channel and hit the bell icon to stay updated with all the latest technologies. Also, if you have any questions related to this video, please put it in the chat section. Our team of experts will help you address your questions. Moving ahead, now we will see the different types of artificial intelligence based on functionalities. In this category, first we have reactive machine. A reactive machine is the basic form of AI that does not store memories or use past experiences to determine future actions. It works only with present data. They simply perceive the world and react to it. Reactive machines are given certain tasks and don't have capabilities beyond those duties. IBM's Deep Blue, which defeated chess grandmaster Garry Kasparov, is a reactive machine that sees the pieces on a chessboard and reacts to them. It cannot refer to any of its prior experiences and cannot improve with practice. Deep Blue can identify the pieces on a chessboard and know how each moves. It can make predictions about what moves might be next for it and its opponent. It can choose the most optimal moves from among the possibilities. Deep Blue ignores everything before the present moment. All it does is look at the pieces on the chessboard as it stands right now and choose from possible next moves. Up next, we have limited memory. Limited memory AI learns from past data to make decisions. The memory of such systems is short-lived. While they can use this data for a specific period of time, they cannot add it to a library of their experiences. This kind of technology is used for self-driving vehicles. They observe how other vehicles are moving around them in the present and as time passes. That ongoing collected data gets added to the static data within the AI machine, such as lane markers and traffic lights. They are included when the vehicle decides to change lanes to avoid cutting off another driver or being hit by a nearby vehicle. Mitsubishi Electric is a company that has been figuring out how to improve such technology for applications like self-driving cars. Then we have theory of mind. Theory of mind represents a very advanced class of technology and exists as a concept. This kind of AI requires a thorough understanding that the people and the things within an environment can alter feelings and behaviors. It should be able to understand people's emotions, sentiment, and thoughts. Even though a lot of improvements are there in this field, this kind of AI is not complete yet. One real-world example of theory of mind AI is Kismet, a robot head made in the late 90s by a Massachusetts Institute of Technology researcher. Kismet can mimic human emotions and recognize them. Both abilities are key advancements in theory of mind AI, but Kismet can't follow gazes or convey attention to humans. Sophia from Hanson Robotics is another example where the theory of mind AI was implemented. Cameras within Sophia's eyes combined with computer algorithms allow her to see. She can follow faces, sustain eye contact, and recognize individuals. She is able to process speech and have conversations using natural language subsystem. Finally, we have self-awareness. Self-awareness AI only exists hypothetically. Such systems understand their internal traits, states, and conditions and perceive human emotions. These machines will be smarter than the human mind. This type of AI will not only be able to understand and evoke emotions in those it interacts with, but also have emotions, needs, and beliefs of its own. While we are probably far away from creating machines that are self-aware, we should focus our efforts towards understanding memory, learning, and the ability to base decisions on past experiences. Let's look at the definition of each of these learning techniques. Supervised learning uses labeled data to train machine learning models. Labeled data means that the output is already known to you. The model just needs to map the inputs to the outputs. An example of supervised learning can be to train a machine that identifies the image of an animal. Below you can see we have our trained model that identifies the picture of a cat. Unsupervised learning uses unlabeled data to train machines. Unlabeled data means there is no fixed output variable. The model learns from the data, discovers patterns and features in the data, and returns the output. Here is an example of an unsupervised learning technique that uses the images of vehicles to classify if it's a bus or a truck. So the model learns by identifying the parts of a vehicle, such as the length and width of the vehicle, the front and rear end covers, roof hoods, the types of wheels used, etc. Based on these features, the model classifies if the vehicle is a bus or a truck. Reinforcement learning trains a machine to take suitable actions and maximize reward in a particular situation. It uses an agent and an environment to produce actions and rewards. The agent has a start and an end state, but there might be different paths for reaching the end state, like a maze. In this learning technique, there is no predefined target variable. An example of reinforcement learning is to train a machine that can identify the shape of an object given a list of different objects such as square, triangle, rectangle, or a circle. In the example shown, the model tries to predict the shape of the object, which is a square here. Now, let's look at the different machine learning algorithms that come under these learning techniques. Some of the commonly used supervised learning algorithms are linear regression, logistic regression, support vector machines, k-nearest neighbors, decision tree, random forest, and naive Bayes. Examples of unsupervised learning algorithms are k-means clustering, hierarchical clustering, dbScan, principal component analysis, and others. Choosing the right algorithm depends on the type of problem you are trying to solve. Some of the important reinforcement learning algorithms are Q-learning, Monte Carlo, SARSA, and Deep Q network. Now let's look at the approach in which these machine learning techniques work. So supervised learning takes labeled inputs and maps it to known outputs, which means you already know the target variable. Unsupervised learning finds patterns and understands the trends in the data to discover the output. So the model tries to label the data based on the features of the input data. While reinforcement learning follows trial and error method to get the desired solution. After accomplishing a task, the agent receives an award. An example could be to train a dog to catch the ball. If the dog learns to catch a ball, you give it a reward such as a biscuit. Now, let's discuss the training process for each of these learning methods. So supervised learning methods need external supervision to train machine learning models, and hence the name supervised. They need guidance and additional information to return the result. Unsupervised learning techniques do not need any supervision to train models. They learn on their own and predict the output. Similarly, reinforcement learning methods do not need any supervision to train machine learning models. And with that, let's focus on the types of problems that can be solved using these three types of machine learning techniques. So supervised learning is generally used for classification and regression problems. We'll see the examples in the next slide. And unsupervised learning is used for clustering and association problems, while reinforcement learning is reward-based, so for every task or for every step completed, there will be a reward received by the agent. And if the task is not achieved correctly, there will be some penalty used. Now, let's look at a few applications of supervised, unsupervised, and reinforcement learning. As we saw earlier, supervised learning are used to solve classification and regression problems. For example, you can predict the weather for a particular day based on humidity, precipitation, wind speed, and pressure values. You can use supervised learning algorithms to forecast sales for the next month or the next quarter for different products. Similarly, you can use it for stock price analysis or identifying if a cancer cell is malignant or benign. Now, talking about the applications of unsupervised learning, we have customer segmentation. So based on customer behavior, likes, dislikes, and interests, you can segment and cluster similar customers into a group. Another example where unsupervised learning algorithms are used is customer churn analysis. Now, let's see what applications we have in reinforcement learning. So reinforcement learning algorithms are widely used in the gaming industries to build games. It is also used to train robots to perform human tasks.
Profit estimation of a company. If I was going to invest in a company, I would like to know how much money I could expect to make. So we'll take a look at a venture capitalist firm and try to understand which companies they should invest in. So we'll take the idea that we need to decide the companies to invest in. We need to predict the profit the company makes, and we're going to do it based on the company's expenses, and even just a specific expense. In this case, we have our company, we have the different expenses, so we have our R&D, which is your research and development, we have our marketing, we might have the location, we might have what kind of administration it's going through. Based on all this different information, we would like to calculate the profit. Now, in actuality, there's usually about 23 to 27 different markers that they look at if they're a heavy-duty investor. We're only going to take a look at one basic one. We're going to come in, and for simplicity, let's consider a single variable R&D and find out which companies to invest in based on that. So when we take our R&D and we're plotting the profit based on the R&D expenditure, how much money they put into the research and development, and then we look at the profit that goes with that. We can predict a line to estimate the profit. So we can draw a line right through the data. And when you look at that, you can see how much they invest in the R&D is a good marker as to how much profit they're going to have. We can also note that companies spending more on R&D make good profit. So let's invest in the ones that spend a higher rate in their R&D. What's in it for you? First, we'll have an introduction to machine learning, followed by machine learning algorithms. These will be specific to linear regression and where it fits into the larger model. Then we'll take a look at applications of linear regression, understanding linear regression, and multiple linear regression. Finally, we'll roll up our sleeves and do a little programming in use case profit estimation of companies. Let's go ahead and jump in. Let's start with our introduction to machine learning, along with some machine learning algorithms and where that fits in with linear regression. Let's look at another example of machine learning. Based on the amount of rainfall, how much would be the crop yield? So here we have our crops, we have our rainfall, and we want to know how much we're going to get from our crops this year. So we're going to introduce two variables, independent and dependent. The independent variable is a variable whose value does not change by the effect of other variables and is used to manipulate the dependent variable. It is often denoted as x. In our example, rainfall is the independent variable. This is a wonderful example because you can easily see that we can't control the rain, but the rain does control the crop. So when we talk about the independent variable controlling the dependent variable, let's define dependent variable as a variable whose value change when there is any manipulation in the values of the independent variables. It is often denoted as y. And you can see here our crop yield is dependent variable, and it is dependent on the amount of rainfall received. Now that we've taken a look at a real-life example, let's go a little bit into the theory and some definitions on machine learning and see how that fits together with linear regression. Numerical and categorical values. Let's take our data coming in, and this is kind of random data from any kind of project. We want to divide it up into numerical and categorical. So numerical is numbers, age, salary, height, where categorical would be a description, the color, a dog's breed, gender. Categorical is limited to very specific items, where numerical is a range of information. Now that you've seen the difference between numerical and categorical data, let's take a look at some different machine learning definitions. When we look at our different machine learning algorithms, we can divide them into three areas: supervised, unsupervised, reinforcement. We're only going to look at supervised today. Unsupervised means we don't have the answers and we're just grouping things. Reinforcement is where we give positive and negative feedback to our algorithm to program it, and it doesn't have the information until after the fact. But today we're just looking at supervised because that's where linear regression fits in. In supervised data, we have our data already there and our answers for a group, and then we use that to program our model and come up with an answer. The two most common uses for that is through the regression and classification. Now we're doing linear regression, so we're just going to focus on the regression side. And in the regression, we have simple linear regression, we have multiple linear regression, and we have polynomial linear regression. Now on these three, simple linear regression is the examples we've looked at so far, where we have a lot of data and we draw a straight line through it. Multiple linear regression means we have multiple variables. Remember where we had the rainfall and the crops? We might add additional variables in there, like how much food do we give our crops? When do we harvest them? Those would be additional information add into our model. And that's why it'd be multiple linear regression. And finally, we have polynomial linear regression. That is, instead of drawing a line, we can draw a curved line through it. Now that you see where a regression model fits into the machine learning algorithms, and we're specifically looking at linear regression, let's go ahead and take a look at applications for linear regression. Let's look at a few applications of linear regression. Economic growth, used to determine the economic growth of a country or a state in the coming quarter, can also be used to predict the GDP of a country. Product price can be used to predict what would be the price of a product in the future. We can guess whether it's going to go up or down, or should I buy today. Housing sales, to estimate the number of houses a builder would sell and what price in the coming months. Score predictions, cricket fever, to predict the number of runs a player would score in the coming matches based on the previous performance. I'm sure you can figure out other applications you could use linear regression for. So let's jump in and let's understand linear regression and dig into the theory. Understanding linear regression. Linear regression is a statistical model used to predict the relationship between independent and dependent variables by examining two factors. The first important one is which variables in particular are significant predictors of the outcome variable. And the second one that we need to look at closely is how significant is the regression line to make predictions with the highest possible accuracy. If it's inaccurate, we can't use it. So it's very important we find out the most accurate line we can get. Since linear regression is based on drawing a line through data, we're going to jump back and take a look at some Euclidean geometry. The simplest form of a simple linear regression equation with one dependent and one independent variable is represented by y equals m times x plus c. And if you look at our model here, we plotted 2 points on here, x1 and y1, x2 and y2. Y being the dependent variable, remember that from before, and x being the independent variable. So y depends on whatever x is. M, in this case, is the slope of the line, where m equals the difference in the y2 minus y1 and x2 minus x1. And finally we have c, which is the coefficient of the line, or where it happens to cross the zero axes. Let's go back and look at an example we used earlier of linear regression. We're going to go back to plotting the amount of crop yield based on the amount of rainfall. And here we have our rainfall. Remember, we cannot change rainfall. And we have our crop yield, which is dependent on the rainfall. So we have our independent and our dependent variables. We're going to take this and draw a line through it as best we can through the middle of the data. And then we look at that, we put the red point on the y-axis is the amount of crop yield you can expect for the amount of rainfall, represented by the green dot. So if we have an idea what the rainfall is for this year and what's going on, then we can guess how good our crops are going to be. And we've created a nice line right through the middle to give us a nice mathematical formula. Let's take a look and see what the math looks like behind this. Let's look at the intuition behind the regression line. Now, before we dive into the math and the formulas that go behind this and what's going on behind the scenes, I want you to note that when we get into the case study and we actually apply some Python script, that this math that you're going to see here is already done automatically for you. You don't have to have it memorized. It is, however, good to have an idea what's going on, so if people reference the different terms, you'll know what they're talking about. Let's consider a sample data set with 5 rows and find out how to draw the regression line. We're only going to do 5 rows because if we did like the rainfall with hundreds of points of data, that would be very hard to see what's going on with the mathematics. So we'll go ahead and create our own 2 sets of data, and we have our independent variable x and our dependent variable y. And when x was 1, we got y equals 2. When x was 2, y was 4, and so on and so on. If we go ahead and plot this data on a graph, we can see how it forms a nice line through the middle. You can see where it's kind of grouped going upwards to the right. The next thing we want to know is what the means is of each of the data coming in, the x and the y. The means doesn't mean anything other than the average. So we add up all the numbers and divide by the total. So 1 plus 2 plus 3 plus 4 plus 5 over 5 equals 3. And the same for y, we get 4. If we go ahead and plot the means on the graph, we'll see we get 3, 4, which draws a nice line down the middle. A good estimate. Here we're going to dig deeper into the math behind the regression line. Now remember before I said you don't have to have all these formulas memorized or fully understand them, even though we're going to go into a little more detail of how it works. And if you're not a math whiz and you don't know, if you've never seen the sigma character before, which looks a little bit like an E that's opened up, that just means summation. That's all that is. So when you see the sigma character, it just means we're adding everything in that row. And for computers, this is great because as a programmer, you can easily iterate through each of the XY points and create all the information you need. So in the top half, you can see where we've broken that down into pieces. And as it goes through the first 2 points, it computes the squared value of x, the squared value of y, and x times y. And then it takes all of x and adds them up, all of y adds them up, all of x squared adds them up, and so on and so on. And you can see we have the sum is equal to 15, the sum is equal to 20, all the way up to x times y, where the sum equals 66. This all comes from our formula for calculating a straight line, where y equals the slope times x plus the coefficient c. So we go down below, and we're going to compute more like the averages of these, and we're going to explain exactly what that is in just a minute, and where that information comes from is called the square means error. But we'll go into that in detail in a few minutes. All you need to do is look at the formula and see how we've gone about computing it line by line instead of trying to have a huge set of numbers pushed into it. And down here you'll see where the slope m equals, and on the top part, if you read through the brackets, you have the number of data points times the sum of x times y, which we computed one line at a time there, and that's just the 66. And take all that and you subtract it from the sum of x times the sum of y. And those have both been computed. So you have 15 times 20. And on the bottom, we have the number of lines times the sum of x squared, easily computed as 86 for the sum, minus, I'll take all that and subtract the sum of x squared. And we end up, as we come across with our formula, you can plug in all those numbers, which is very easy to do on the computer. You don't have to do the math on a piece of paper or a calculator. And you'll get a slope of 0.6. And you'll get your c coefficient. If you continue to follow through that formula, you'll see it comes out as equal to 2.2. Continuing deeper into what's going behind the scenes, let's find out the predicted values of y for corresponding values of x using the linear equation where m equals 0.6 and c equals 2.2. We're going to take these values and we're going to go ahead and plot them. We're going to predict them, so y equals 0.6 times where x equals 1, plus 2.2 equals 2.8, so on and so on. And here, the blue points represent the actual y values, and the brown points represent the predicted y values, based on the model we created. The distance between the actual and predicted values is known as residuals or errors. The best fit line should have the least sum of squares of these errors, also known as e square. If we put these into a nice chart where you can see x and you can see y, what we actual values were, and you can see y predicted, you can easily see where we take y minus y predicted and we get an answer. What is the difference between those two? And if we square that, y minus y prediction squared, we can then sum those squared values. That's where we get the 0.64 plus the 0.36 plus 1, all the way down until we have a summation equals 2.4. So the sum of squared errors for this regression line is 2.4. We check this error for each line and conclude the best fit line having the least e-square value. In a nice graphical representation, we can see here where we keep moving this line through the data points to make sure the best fit line has the least square distance between the data points and the regression line. Now, we only looked at the most commonly used formula for minimizing the distance. There are lots of ways to minimize the distance between the line and the data points, like sum of squared errors, sum of absolute errors, root mean square error, etc. What you want to take away from this is whatever formula is being used, you can easily, using a computer programming and iterating through the data, calculate the different parts of it. That way, these complicated formulas you see with the different summations and absolute values are easily computed one piece at a time. Up until this point, we've only been looking at two values, x and y. Well, in the real world, it's very rare that you only have two values when you're figuring out a solution. So let's move on to the next topic, multiple linear regression. Let's take a brief look at what happens when you have multiple inputs. So in multiple linear regression, we have, we'll start with the simple linear regression, where we had y equals m plus x plus c, and we're trying to find the value of y. Now with multiple linear regression, we have multiple variables coming in. So instead of having just x, we have x1, x2, x3. And instead of having just one slope, each variable has its own slope attached to it. As you can see here, we have m1, m2, m3, and we still just have the single coefficient. So when you're dealing with multiple linear regression, you basically take your single linear regression and you spread it out. So you have y equals m1 times x1 plus m2 times x2, so on all the way to m to the nth, x to the nth, and then you add your coefficient on there. Implementation of linear regression. Now we get into my favorite part. Let's understand how multiple linear regression works by implementing it in Python. If you remember before, we were looking at a company and just based on its R&D, trying to figure out its profit. We're going to start looking at the expenditure of the company. We're going to go back to that and we're going to predict its profit. But instead of predicting it just on the R&D, we're going to look at other factors like administration costs, marketing costs, and so on. And from there, we're going to see if we can figure out what the profit of that company is going to be. To start our coding, we're going to begin by importing some basic libraries. And we're going to be looking through the data before we do any kind of linear regression. We're going to take a look at the data to see what we're playing with. Then we'll go ahead and format the data to the format we need to be able to run it in the linear regression model. And then from there, we'll go ahead and solve it and just see how valid our solution is. So let's start with importing the basic libraries. Now, I'm going to be doing this in Anaconda Jupyter Notebook, a very popular IDE. I enjoy it because it's such a visual to look at and it's so easy to use. Just any IDE for Python will work just fine for this. So break out your favorite Python IDE. So here we are in our Jupyter Notebook. Let me go ahead and paste our first piece of code in there. And let's walk through what libraries we're importing. First, we're going to import NumPy as NP. And then I want you to skip one line and look at import pandas as PD. These are very common tools that you need with most of your linear regression. The NumPy, which stands for NumPython, is usually denoted as NP, and you have to almost have that for your sklearn toolbox. So you always import that right off the beginning. Pandas, although you don't have to have it for your sklearn libraries, it does such a wonderful job of importing data, setting it up into a data frame so we can manipulate it rather easily, and it has a lot of tools also in addition to that. So we usually like to use the pandas when we can, and I'll show you what that looks like. The other three lines are for us to get a visual of this data and take a look at it. So we're going to import matplotlibary.pyplot as PLT and then Seaborn as SNS. Seaborn works with the matplot library. So you have to always import matplotlibary and then Seaborn sits on top of it. And we'll take a look at what that looks like. You could use any of your own plotting libraries you want. There's all kinds of ways to look at the data. These are just very common ones, and the Seaborn is so easy to use that it just looks beautiful. It's a nice representation that you can actually take and show somebody. And the final line is the ampersand matplotlib inline. That is only because I'm doing an inline IDE. My interface in the Anaconda Jupyter Notebook requires I put that in there, or you're not going to see the graph when it comes up. Let's go ahead and run this. It's not going to be that interesting because we're just setting up variables. In fact, it's not going to do anything that we can see, but it is importing these different libraries and setup. The next step is load the data set and extract independent and dependent variables. Now, here in the slide, you'll see companies equals pd.read CSV, and it has a long line there with the file at the end, 1000companies.csv. You're going to have to change this to fit whatever setup you have. And the file itself, you can request. Just go down to the commentary below this video and put a note in there, and Simplilearn will try to get in contact with you and supply you with that file so you can try this coding yourself. So we're going to add this code in here, and we're going to see that I have companies equals pd.reader_csv, and I've changed this path to match my computer, c:/Simplilearn/1000_companies.csv. And then below there, we're going to set the x equals to companies under the I location, and because this is companies is a PD data set, I can use this nice notation that says take every row, that's what the first colon is, comma, except for the last column. That's what the second part is, where we have a :-1, and we want the values set into there. So X is no longer a data set, a pandas data set, but we can easily extract the data from our pandas data set with this notation. And then Y, we're going to set equal to the last row. Well, the question is going to be, what are we actually looking at? So let's go ahead and take a look at that. And we're going to look at the companies.head, which lists the first 5 rows of data. And I'll open up the file in just a second so you can see where that's coming from. But let's look at the data in here as far as the way the pandas sees it. When I hit run, you'll see it breaks it out into a nice setup. This is what pandas, one of the things pandas is really good about, is it looks just like an Excel spreadsheet. You have your rows, and remember, when we're programming, we always start with 0. We don't start with 1. So it shows the first 5 rows. 0, 1, 2, 3, 4, and then it shows your different columns: R&D spend, administration, marketing spend, state, profit. It even notes that the top are column names. It was never told that, but Pandas is able to recognize a lot of things that they're not the same as the data rows. Why don't we go ahead and open this file up in a CSV so you can actually see the raw data. So here I've opened it up as a text editor, and you can see at the top we have R&D spend, comma, administration, comma, marketing spend, comma, state, comma, profit, carriage return. I don't know about you, but I'd go crazy trying to read files like this. That's why we use the pandas. You could also open this up in an Excel and it would separate it, since it is a comma-separated variable file. But we don't want to look at this one. We want to look at something we can read rather easily. So let's flip back and take a look at that top part, the first 5 rows. Now, as nice as this format is, where I can see the data, to me it doesn't mean a whole lot. Maybe you're an expert in business and investments and you understand what $165,349.20 compared to the administration cost of $136,897.80, so on, helps to create the profit of $192,261.83. That makes no sense to me whatsoever. No pun intended. So let's flip back here and take a look at our next set of code where we're going to graph it so we can get a better understanding of our data and what it means. So at this point, we're going to use a single line of code to get a lot of information so we can see where we're going with this. Let's go ahead and paste that into our notebook and see what we got going. And so we have the visualization, and again we're using SNS, which is pandas. As you can see, we imported the matplot library, .pyplot as PLT, which then the Seaborn uses. And we imported the Seaborn as SNS. And then that final line of code helps us show this in our inline coding. Without this, it wouldn't display, and you could display it to a file and other means. And that's the matplot library inline with the ampersand at the beginning. So here we come down to the single line of code. Seaborn is great because it actually recognizes the Panda data frame. So I can just take the companies.core for coordinates, and I can put that right into the Seaborn. And when we run this, we get this beautiful plot. And let's just take a look at what this plot means. If you look at this plot, on mine the colors are probably a little bit more purplish and blue than the original one. We have the columns and the rows. We have R&D spending, we have administration, we have marketing spending, and profit. And if you cross-index any 2 of these, since we're interested in profit, if you cross-index profit with profit, it's going to show up, if you look at the scale on the right, way up in the dark. Why? Because those are the same data. They have an exact correspondence. So R&D spending is going to be the same as R&D spending, and the same thing with administration costs. So right down the middle, you get this dark row, or dark diagonal row, that shows that this is the highest corresponding data. That's exactly the same. And as it becomes lighter, there's less connections between the data. So we can see with profit, obviously profit is the same as profit. And next, it has a very high correlation with R&D spending, which we looked at earlier. And it has a slightly less connection to marketing spending, and even less to how much money we put into the administration. So now that we have a nice look at the data, let's go ahead and dig in and create some actual useful linear regression models so that we can predict values and have a better profit. Now that we've taken a look at the visualization of this data, we're going to move on to the next step. Instead of just having a pretty picture, we need to generate some hard data, some hard values. So let's see what that looks like. We're going to set up our linear regression model in 2 steps. The first one is we need to prepare some of our data so it fits correctly. And let's go ahead and paste this code into our Jupyter notebook. And what we're bringing in is we're going to bring in the sklearn pre-processing, where we're going to import the label encoder and the one hot encoder. To use the label encoder, we're going to create a variable called label encoder and set it equal to capital L label capital E encoder. This creates a class that we can reuse for transferring the labels back and forth. Now about now you should ask, what labels are we talking about? Let's go take a look at the data we processed before and see what I'm talking about here. If you remember when we did the companies.head and we printed the top 5 rows of data, we have our columns going across. We have column 0, which is R&D spending, column 1, which is administration, column 2, which is marketing spending, and column 3 is state. And you'll see under state we have New York, California, Florida. Now, to do a linear regression model, it doesn't know how to process New York. It knows how to process a number. So the first thing we're going to do is we're going to change that New York, California, and Florida, and we're going to change those to numbers. That's what this line of code does here. X equals, and then it has the colon comma 3 in brackets. The first part, the colon comma, means that we're going to look at all the different rows. So we're going to keep them all together. But the only row we're going to edit is the 3rd row. And in there we're going to take the label coder and we're going to fit and transform the X, also the 3rd row. So we're going to take that 3rd row, we're going to set it equal to a transformation. And that transformation basically tells it that instead of having a New York, it has a 0 or a 1 or a 2. And then finally we need to do a one hot encoder, which equals one hot encoder categorical features equals 3. And then we take the X and we go ahead and do that equal to one hot encoder fit transform X to array. This final transformation preps our data for us so it's completely set the way we need it as just a row of numbers. Even though it's not in here, let's go ahead and print X and just take a look at what this data is doing. You'll see you have an array of arrays, and then each array is a row of numbers. And if I go ahead and just do row 0, you'll see I have a nice organized row of numbers that the computer now understands. We'll go ahead and take this out there because it doesn't mean a whole lot to us. It's just a row of numbers. Next, on setting up our data, we have avoiding dummy variable trap. This is very important. Why? Because the computer has automatically transformed our header into the setup, and it's automatically transformed all these different variables. So when we did the encoder created 2 columns. And what we need to do is just have the 1, because it has both the variable and the name. That's what this piece of code does here. Let's go ahead and paste this in here, and we have X equals X colon comma 1 colon. All this is doing is removing that one extra column we put in there when we did our one hot encoder and our label encoding. Let's go ahead and run that. And now we get to create our linear regression model. And let's see what that looks like here. And we're going to do that in 2 steps. The first step is going to be in splitting the data. Now, whenever we create a predictive model of data, we always want to split it up so we have a training set and we have a testing set. That's very important. Otherwise, we'd be very unethical without testing it to see how good our fit is. And then we'll go ahead and create our multiple linear regression model and train it and set it up. Let's go ahead and paste this next piece of code in here. And I'll go ahead and shrink it down a size or 2 so it all fits on one line. So from the sklearn module selection, we're going to import train, test, split. And you'll see that we've created 4 completely different variables. We have capital X train, capital X test, smaller case y train, smaller case y test. that is the standard way that they usually reference these when we're doing different models. You usually see that a capital X, and you see the train and the test and the lowercase y. What this is X is our data going in. That's our R&D spend, our administration, our marketing. And then Y, which we're training, is the answer. That's the profit. Because we want to know the profit of an unknown entity. So that's what we're going to shoot for in this tutorial. The next part, train, test, split, we take X and we take Y. We've already created those. X has the columns with the data in it, and Y has a column with profit in it. And then we're going to set the test size equals 0.2. That basically means 20%. So 20% of the rows are going to be tested. We're going to just put them off to the side. So since we're using 1,000 lines of data, that means that 200 of those lines we're going to hold off to the side to test for later. And then the random state equals 0. We're going to randomize which ones it picks to hold off to the side. We'll go ahead and run this. It's not overly exciting because it's setting up our variables. But the next step we actually create our linear regression model. Now that we got to the linear regression model, we get that next piece of the puzzle. Let's go ahead and put that code in there and walk through it. So here we go. We're going to paste it in there. And let's go ahead and, since this is a shorter line of code, let's zoom up there so we can get a good look. And we have from the sklearn.linear_model, we're going to import linear regression. Now, I don't know if you recall from earlier when we were doing all the math. Let's go ahead and flip back there and take a look at that. Do you remember this, where we had this long formula on the bottom and we were doing all this summization? And then we also looked at setting it up with the different lines. And then we also looked all the way down to multiple linear regression, where we're adding all those formulas together. All of that is wrapped up in this one section. So what's going on here is I'm going to create a variable called regressor. And the regressor equals the linear regression. That's a linear regression model that has all that math built in. So we don't have to have it all memorized or have to compute it individually. And then we do the regressor.fit. In this case, we do xtrain and ytrain because we're using the training data. X being the data in and Y being profit, what we're looking at. And this does all that math for us. So within one click and one line, we've created the whole linear regression model. And we fit the data to the linear regression model. And you can see that when I run the regressor, it gives an output, linear regression. It says copy X equals true, fit intercept equals true, in jobs equal 1, normalize equals false. It's just giving you some general information on what's going on with that regressor model. Now that we've created our linear regression model, let's go ahead and use it. And if you remember, we kept a bunch of data aside. So we're going to do a yPredict variable, and we're going to put in the xTest. And let's see what that looks like. Scroll up a little bit, paste that in here. Predicting the test set results. So here we have yPredict equals regressor.predict xTest going in, and this gives us yPredict. Now because I'm in Jupyter inline, I can just put the variable up there, and when I hit the run button, it'll print that array out. I could have just as easily done print yPredict. So if you're in a different IDE that's not an inline setup like the Jupyter Notebook, you can do it this way, print yPredict. And you'll see that for the 200 different test variables we kept off to the side, it's going to produce 200 answers. This is what it says the profit are for those 200 predictions. But let's don't stop there. Let's keep going and take a couple look. We're going to take just a short detail here and calculating the coefficients and the intercepts. This gives us a quick flash at what's going on behind the line. We're going to take a short detour here, and we're going to be calculating the coefficient and intercepts. So you can see what those look like. What's really nice about our regressor we created is it already has the coefficients for us. We can simply just print regressor.coefficient underscore. When I run this, you'll see our coefficients here. And if we can do the regressor coefficient, we can also do the regressor intercept. And let's run that and take a look at that. This all came from the multiple regression model, and we'll flip over so you can remember where this is going into and where it's coming from. You can see the formula down here where y equals m1 times x1 plus m2 times x2 and so on plus c, the coefficient. So these variables fit right into this formula. Y equals slope 1 times column 1 variable plus slope 2 times column 2 variable all the way to the m into the n and x to the n plus c, the coefficient. Or in this case, you have minus 8.89 to the power of 2, etc., times the first column and the second column and the third column. And then our intercept is the minus 103009 point. Boy, it gets kind of complicated when you look at it. This is why we don't do this by hand anymore. This is why we have the computer to make these calculations easy to understand and calculate. Now, I told you that was a short detour, and we're coming towards the end of our script. As you remember from the beginning, I said if we're going to divide this information, we have to make sure it's a valid model, that this model works, and understand how good it works. So, calculating the R-squared value. That's what we're going to use to predict how good our prediction is. And let's take a look at what that looks like in code. And so we're going to use this from sklearn.metrics. We're going to import R2 score. That's the R-squared value. And we're looking at the error. So, in the R2 score, we take our y-test versus our y-predict. Y-test is the actual values we're testing. That was the one that was given to us so we know are true. The Y-predict of those 200 values is what we think it was true. And when we go ahead and run this, we see we get a 0.9352. That's the R2 score. Now, it's not exactly a straight percentage, so it's not saying it's 93% correct. But you do want that in the upper 90s, and higher, shows that this is a very valid prediction based on the R2 score. And if R-squared value of 0.91, or 92 as we got on our model, because remember it does have a random generation involved, this proves the model is a good model, which means success! Yay! We successfully trained our model with certain predictors and estimated the profit of the companies using linear regression. So why linear regression? Now that we have come this far, I'm planning to take a closer look at our cells so that we can estimate cells in the future. How about we hire a data scientist? You can see our two corporate individuals. It looks more like they should be agents or secret agents someplace, discussing how to better forward their company. And so they're going to come in and ask the data scientist to come in. Good idea. This will help us to keep a constant track of our cells. So why do we need linear regression? Let's assume that we need to predict the number of skiers based on snowfall. So this happens to be, we've kind of jumped one business to the next. So we're looking at the skiing business, very popular in a lot of areas. And it's based on snowfall a lot of times. You figure you don't have snow, you don't have skiers. But can we actually use something more specific instead of, look, it's snowing? And instead of saying, hey, look, it's snowing, we can actually start drawing graphs. And the graph shows that with an increase in snowfall, the frequency of skiers also increases. So, and there's a pretty direct correlation. If you've ever been up to the ski areas, when there's a lot of snowfalls, the skiers all show up because they know it's going to be better skiing right afterward. So it's kind of easy to see why skiers and snowfall would go together. And it usually draws a nice straight line. And you can easily predict how many skiers, and that way you can also predict how many people you need to service them, how many lifts to have up and running, and all the stuff that goes with running a ski area. Thus, we see that the number of skiers are directly proportional to the amount of snowfall. Regression models a relation between a dependent y and an independent x variable. This is real important to understand regression, because when we talk about linear regression, it's the basis of almost all our machine learning algorithms out there, and it's usually an underlying part of the math in our deep learning. So it all starts here with linear regression. And when we talk about a dependent y and an independent x variable, these are numbers. We're usually talking about floats. So we want to have an actual number value coming out. And that's different than something that's categorical, where we want to know yes or no, true, false. So regression means we're looking for a number. The independent variable is known as predictor variable, and dependent variable is known as the response variable. So we have one predictor variable, the amount of snowfall, and one response variable, how many skiers are going to show up. And then we can take this relationship and it can be expressed as y equals beta. We're going to use the Greek letter beta, and we have beta naught plus beta 1 x1. And if you continue out, it'd be plus beta 2, x2, and so on till the nth degree. In this case, snowfall is an independent variable, and skiers is a dependent variable. So we kind of had a little quick overview. Let's go ahead and talk a little bit more about what is linear regression. So we're going to go from y, predicting a number of skiers for snowfall, and we looked at the formula a little bit, but let's look a little bit closer at what exactly is going on with linear regression. And the question is going to come up in an interview. What is linear regression? Linear regression is a type of statistical analysis that attempts to show the relationship between two variables. Linear regression creates a predictive model on any data showing trends in data. The model is found by using the least square method. There are other methods. The least square method happens to be the most commonly used out there. And we usually start with the least square method since it's the most common and usually works the best on most models. And we're already looking at how linear regression works, but let's dig deeper into it and let's take a closer look. How linear regression works. I will provide you with a data set which has rent, area, other information in it. It looks like our secret agents have put on their casual wear for this one. You need to predict rent accordingly. We are given area and rent here. So you can do linear regression with more variables, but we're just going to look at the area and then from that try to figure out what the rent should be. We plot the graph. And if you look at it here, you can see that the graph is kind of a linear pattern with a little dip in it. So the rent seems to be based on the area. In most of our work as data scientists, we usually try to start with a physical graph if we can. So we can actually look at it and say, hey, does what I'm fitting to this graph look right? You can solve a lot of problems that arise by looking at the graph and saying, no, that doesn't look right at all. Or, oh, I should be looking over here for this. Then we find the mean of area and rent. So the mean just means average. And if you take 1, 2, 3, 4, 5 and add them all together and divide by, in this case, there's 5 areas, you get 3. And the rent is 2, 4, 6, 5, and 8. If you add them all together and divide by 5, you get 5. And we plot the mean on the graph. So you can see right here, here's the mean of the rent and the area. It's kind of a very central point, which is what we're looking for, the average of everything in there. The best fit line passes through the mean. This is real important. When you're eyeballing it, as humans, we can do this fairly easy if it's a straight line through a bunch of data. It gets more complicated mathematically when you start adding multiple variables and instead of a line you have a curve. But for basic linear regression, we're going to draw a line through the data and the line should go through the means. That's going to be part of the best fit for that line. But we see there are multiple lines that can pass through the means. So depending on how you look at it, you can kind of wiggle the line around back and forth. So we keep moving the line to ensure that the best fit line has the least square distance from the data points. And this is, you can see right here residual, we have our data point and then we look at this distance between them and we square that distance. And that's what they mean by the least squared distance. We want all those distances to add up to the smallest amount we can. When we talk about that distance, we call it the residual. It equals the y actual minus the y predicted. Very straightforward, we're just looking at the distance. You can accidentally switch these and it'll come out the same because we're going to square it. But when you're working with other sets of linear regression, you want to make sure you do the y actual minus the y predicted. The value of m and c for the best fit line, y equals mx plus c, can be calculated using the mentioned formula. And you can see here we have m equals the number of points, that's what n stands for. Then we have the sigma, the Greek symbol is there, which is a summation of x times y minus the summation of x times the summation of y over the number of the summation of x squared minus the summation of x squared, of x, all of it squared. That can be a little confusing trying to say that. And then of course your c value is going to be the summation of y times the summation of x squared minus the summation of x times the summation of x times y over the total count of the summation x squared minus the summation of x squared. That's a mouthful. Normally we don't worry too much about these formulas other than to know they're there. Now if you're a mathematician, you might go back in there and work on those. And those people who originally started to put together the different models in R, of course, had to know all this math to build them and had to test it out. That's one of the nice things about R. What is important is that you know about these formulas so that you know where it's coming from. So if you're using one linear regression model, this is how this one works. There's other linear regression models based on different math. And so you'd have to be aware when that math changes and how that changes the model. We find the corresponding values. So in this case, if you're going to break this up and you're building your own model instead of using the one in R, you would have your rent, you would have your area, you would find your rent squared, your area squared, and your rent times area. And if we go back one, we can see that that's all the different little pieces in this model. We have x times y, we have x squared, we have the sum of x, which is going to be squared, we have the sum of x, the sum of y. This is the same. These are all the little pieces in here that we see for m equals and c equals. And so once we compute all these, we have 15, 25, 55, 145, 88. Very easy to do on a computer, thankfully. You could have millions of these points and it would do it in a very short period. We can then plug in those values very easily into this formula and get a final answer. And we'll see that m equals 1.3 and c equals 1.1. And then when we take this for the y predicted equals m of I, x of I plus c, we can take these and actually run the data we have. So we're going to see how it predicts. So now we find the value of y predicted. So we have our xn, and we want to know what we think y will be based on our formula we generated, the linear regression formula. And so when we come in here, we have our x, we have our actual y, then we have our y predict, what we think it's going to be. And then we have, we take y minus y predict, and we get those values, minus 0.4, it's off by 0.3, this one's off by 1, this one's off by minus 1.3, by 0.4. And we go ahead and square that, and then we can sum that square and average it out, and we'll get a value. This is just a summation down here of y minus y predicted square is 3.1. And we call that the least square value for this line is 3.1, and we go ahead and divide that by 5. So when we plot the y predict, and this is the best fit line, and you can see that it does a pretty good job going right through the middle of lines. And in something like rent versus area, if you're trying to figure out how much rent to charge or how many people are allowed to be in the area that's going to work. But if you're looking for the rent value compared to the area, this gives you a good idea based on the area of what you should rent the place for. It's close enough that in the business world this would work. You're not computing something down to the millimeters or micrometers or nuclear physics. We're just charging people. And so if you're off by a couple of dollars, it's not a big deal. You'll be pretty close to what you think it's worth and get the right value for your property. Use case. Predicting the revenue using linear regression. Now that you have a good idea of how linear regression works, and we're kicking back on our lounging sofa today, let's work on a real life scenario where you have to predict the revenue. So we're going to take a data set, and we'll pull this up in just a minute. We'll have paid, organic, social, and revenue. There are 3 attributes we'll be working on. The first one is our paid traffic, so all the traffic through the advertisement that comes in. The non-paid traffic from search engines. So these are people coming to the website and are doing so because they did a search for something specific, so it's pulling it from your website. All the traffic coming from social networking sites. So we want to know what's coming from Twitter and Facebook, and somehow they've linked into your website and coming into your marketing area to buy something. And we'll use this to predict the revenue. So we want to know how all this traffic comes together and how it's going to affect our sales if the traffic's coming in. We're going to make use of the multiple linear regression model. So you'll see that this is very similar to what we had before, where we had y equals m times x plus c, but instead we have y equals m1 x1 plus m2 x2 plus m3 x3 plus c. M is the slope, so you have m1, m2, m3, the 3 different slopes of the 3 different lines. Y is the revenue, so we're only looking for one variable. And remember, this is regression, so we're looking for a number. X1 is going to be the paid traffic, and of course M1 the corresponding slope, X2 the organic traffic, and X3 the social traffic. We will follow these steps to create the regression model. We'll start by generating inputs using the CSV files. We'll then import the libraries, splitting the data into train and test. Very important whenever you're doing any kind of data science. Applying regression on paid traffic, organic traffic, social traffic. So we're going to apply a regression model on them. And then we're going to validate the model. That's the whole reason we split it to a training and testing, is so we can now validate to see just how good our model is. Now before we open up R, I always like to just take a quick look at the data itself, and we're using the rev.csv file, and this is a .cs file or a comma separated variable file. We'll just open that with WordPad. Any kind of text editor would be nice to show you what's going on. And you can see we have paid, organic, social, and revenue across the top. So those are your titles for your columns, and the values going down. And this is the same as what we saw on the slide just a minute ago. Paid, organic, social, and then the revenue from them. They probably have it in more of a spreadsheet than just a WordPad. And I'm using the newer version of RStudio, which already has a nice layout. It automatically opens up with your console and terminal window down and left. You have your script, and we'll run it in script, and then when I run it line by line in script, you'll see it show up on the console bottom left. I could type it straight into the console and it would do the same thing. And then on the right we have our environment, and under the environment we'll see plots. If you're in an older version, the plots will pop up, and you usually are running just in the console, and then you have to open up a different window to run the script, and you can run the script from there. This opens up everything at the same time when you use the new RStudio setup. And the first thing we want to do is we want to go ahead and generate a variable. We'll call it cells. And we want to load this with our data set. And so in R, we use the less than minus sign. That's the same as assigned to. It's like an arrow pointing at cells. And it says whatever it goes past here is going to be assigned to cells. And we want to read in our CSV file. And then I went ahead and fixed the CSV file up a little bit. When I say the CSV file, I mean the path to it. And we'll go ahead and just paste that in there. And this is my edited version. And you'll see I took wherever we had the backward slash, I switched it for a forward slash, because a backward slash is an escape character, and whenever you're programming in just about any scripting language, you want to do the forward slash instead. So like a good chef, I prepped this and copied it into my clipboard, and we can see the full path here, and the full path ends in our rev.csv file. So that's the path on my machine. And then I'm going to run that, and now we have down here, you see it appear right here. Uh-oh, must have an error in my path. It says object rev not found. Let me fix that real quick and run it again, and this time it does assign the cells the data set, and then we'll just type in cells, and this is the same as printing it. So if you work in other languages, you'll do like print and then cells, or maybe print cells.head if you're in pandas in Python or something like that. But in R, you just type in the variable. We'll run this, and you can see it printed out all those columns. So that's the same thing we just looked at. And it says max print, so it omitted 750 rows, so it has a total of 1,000 rows. And we can scroll up here on our console where the answer came in. And if I scroll up to the top, way up to the top, there we go, you'll see paid, organic, social, and revenue. So everything looks good on this. And then there's a lot of cool things we can do with it. One of the things we can do is I can summary it. So let's do a summary of cells, and we'll run that. And the summary of cells comes in. It tells you your min, first quarter, median, mean, third quarter, max for paid, organic, social. Breaks it up, and you can actually get kind of a quick view as to what the data is doing. You can take more time to study this. A lot of people look at this, and you can see from the median, the mean, that tells you a lot. And it's divided into quarters, so you have your first quarter value and your third quarter set up on there, and max. It just gives you a quick idea of what's going on in the data. The summary is a really wonderful tool. One of the reasons I like to jump into R before I might do a major project in something else, or you can run everything in R. And let's take a look at the head of cells, and let me run this. And you can see it just shows the head of our data, the first 6 rows in this case, and it starts with 1. Important to know, other different systems start with 0 and go up. R is one that starts with the first as 1. And then if we want to do a plot, I'll go ahead and do a plot cells. Another really powerful tool that you can just jump right into with R once you have your data in here. And you'll see that the plot comes over on the right hand side. And what it does is it compares them. So if I look at my paid and my organic, and you cross the 2, you'll see there's a nice line down the middle, big black line where it plots the 2 together. Let me just widen this a little bit so we can see more of it. There we go. The same thing with paid and social, paid and revenue. So each one of these has a clear connection to each other. So that's a good sign. We have a nice correlation between the data, and you can just eyeball that. That's a good way to jump in and explore your data rather quickly and see what's going on. So we'll go ahead and I'll put a pound sign there. Hashtag, and splitting the data into training and test data. And we want to split it so that we have something to work with to train our data set. And when we do our data set, you do this with any data set because you want to make sure you have a good model. And then once we've trained it, we're going to take the other set of data we pulled off to the side and we'll test it to see how good it is. If you test it with the training data, it's already got that memorized and should give you a really good answer. In fact, when you get into more advanced machine learning tools, you watch those very closely. You watch your training set and how it does versus your testing set. And if your training set starts doing better than your testing set, then you're starting to overtrain it. Now that's more with deep learning and some other packages that are beyond what we're working with today. But this is important. It's very important to understand that that test and that training correlate with each other and gives you an idea of what's going on. And make sure that you're set up correctly. And we'll go ahead and set a seed of 2, and that's for our random generators, so that when we run them, you could seed them with just there's ways to randomize a number, you could do like date and stuff like that, but that way we always use the same random numbers. So we'll seed it with 2, and then we're going to need a library. In this case, we're going to import the library, and we want to import CA tools. And CA Tools has our split function, so we're going to be able to split our data, along with many of the other tools we're going to need for this example. So they're all built into the CA Tools. That's why we need to import that. A lot of times they call them library, or sometimes you hear them referred to as packages. So let's go ahead and run that line. And that brings the library in, so now we can use all those different tools that are in there. And then I'm going to do a split, and we're going to assign to the split, that's going to be our variable, sample split. Okay, so that's one of the tools we just brought in, is to sample is the actual keyword or the function word, sample.split. And we're going to take our cells, and we're going to go ahead and do a split ratio equals to 0.7, and let's do 0.7 so we make sure it knows it's a decimal point or a float. And what this is saying is that we're going to take our cells data, the variable we created called cells that has the data in there, and I want to split it, and I'm going to split it so that 70% of it goes in one side, we'll use that for training, and 30% will go into the other side, which we'll use then for testing out our model. Let me go ahead and run that, and let's hold on one second. Got an error there. Spit is definitely very different than split. I don't think we want to spit our data out, which is actually kind of what we're doing, is spitting it out. But we want to split. We want to split the data. So let me get that spelled correctly. And then when I type in split, we can just run that because that's now a variable. You'll see that it has true, false, false, true. So it generates a number of interesting different statistics going across there as far as the way it splits the data. And right here, if you have not used R in a while, or if you're new to R completely, that line 1, that's what that little 1 means down there, and then true, false, false, true. That means that's how we're looking at the data. We're splitting all those different pieces of data in line 1, different directions. And so we now want to create our train set, and we're going to assign that. And when we take it and we assign to the train set a subset of cells, and then the subset of cells is going to be based on split equal, I put this in brackets, true. So you can see the values down here is capital T, capital R, capital U, capital E. So I just want to reflect that on the train. And this is going to take everything where our split variable is equal to true, and it's going to set cells equal to that. And we'll go ahead and run that. And then we're going to set our test variable as a subset of cells, and if we assign the true to the train set, then we want to assign the false to our test set. So now we'll have this will have 30% of the variables in it, and train will have 70%. We'll go ahead and run that. So we've now created both our training set and our test set, and we can just real quickly type in train, hit the run on there, and you can see our train set. If we scroll way up to the top, I'll have the column names on there, which should match what we had before. Paid, organic, social, and revenue. And then we'll type in test. When I hit run on there, that's going to do the same thing. It'll spit out all the test variables going out. So now that we have the test and train variables, we want to go ahead and create the model. And you'll see this in any of the machine learning tutorials. They always refer to them as models. We're modeling a function of some kind on the data to fit the data, and then we're going to put the test data through there to see how well it does. And so we're going to create the variable called models, and I'm going to assign that LM, that is our linear regression model. I love how simplified R makes it. Just LM, linear regression, and then model, M. I guess it dates back because the linear regression model is like one of the first major models used, so they kept it easy on there. And revenue happens to be the main variable that we want to track. So if you remember correctly from our formula, Y is the revenue, and then we have X is our paid traffic, X2 our organic traffic, and X3 our social traffic. So Y is what we want to predict in here. And then you'll see this notation where we have our squiggle and the period, which means we're going to match up the revenue lines with the lines of the data we're putting in here. And then I'll put comma, and then our data equals train. And of course that's the training data that we created. So when I hit the run, remember we did all that discussion about all those different functions and formulas to compute our model and how that's set up. When it comes down to it, we spend all our time setting up our data, and then I hit the run button on the single line, and our model's been trained. So we now have a trained model here. And we can do a summary of the model. Summary is such a wonderful command because you can do that on R. That works on all kinds of different things on there. Oops. And of course it does help if I remember that my model has a capital N when I run it. And you'll see right here, it tells you a little bit about the model. Use a summary on there. Comes down here, it has our residuals. This is all the information on there as far as like the minimum, the median, the max. It has all our coefficients in there. if you remember correctly from our formula. Let's just go ahead and switch back over to that. We have M1, X1, M2, X2, M3, X3 plus C. Well, that's right here. Here's our intercept, and then we have our different values for each of these. So we have our intercept, our paid, organic, and social. And then it also shows us error and information on the error. And one of the really nice things about when you're working with R, you can come down here and you see where we have our stars down here, and it says 3 stars, really good. 2 stars, maybe. 1 star, probably no correlation. And we can see with all of these, it has 3 stars on them. So out of 3 stars, we get 3 stars on all of these. There's no 4 stars. 4 stars would mean that you have the exact same data going in as coming out. And then if we're going to do this, we want to actually run a prediction on here, and that's what we saved our test data for. So let's come down here, we'll do our prediction. We'll take this variable and we'll assign it predict model. And remember, the predict comes from when we imported that package, the CA tools. That's all part of the CA tools in there. So we're going to predict, we're going to use the model, and then we're going to use our test data. Pretty straightforward, quick and easy. We'll run this, and then if we go ahead and type in the predict, it'll print out what's in that variable. And you'll see down here the predicted values it expects to come out. It's going to say our revenue is. And it goes through and it gives it both the line number and the actual revenue value. So that's quick and easy. Boy, we got a prediction really fast. And this is also how you would do it if you had new data coming in after this. You could predict the revenue based on these other factors. So now that we have a training model, or we trained the data with our training data, or we trained the model with our training data, and we've done a prediction on our model with our test data, we want to look this up, and we took a quick glance from our training thing. Our training said it trained really well. But that's not the final word on it. The final word is going to be comparing it. So we want to go ahead and we're going to do comparing predicted versus actual values. What I'm going to do is I'm going to do a plot, and I'm going to do our test, and we're going to do test revenue.type equals, and we're going to put this in as a type 1 and then, or L, and then we have LTY equals 1.8, and we're going to set it for column blue. That's a lot of stuff in there. Let's go ahead and just run that so we can see what that looks like and what's that's doing. It's going to generate this nice graph we see on the right. There's our graph. You can see the data comes up and down. We're plotting the prediction on there, so this is the values we predicted. And then let's go ahead and do lines. And I actually did this backwards, so let me try that again. And we'll start with the red one. We're going to do the first one in red. And I want to start with the actual test revenue. So here's our test revenue, and we'll go ahead and run this. And so we have our red plot over here in red. Go ahead and take a look at that. Pull that over, you can see how that looks. It goes up and down, hard to track there. And then we're going to do a couple things here. We'll plot our test revenue. And then we'll make it a little pretty, although it's kind of hard to see the way I have it scrunched up here on the right as far as size and sizing and everything. But we'll go ahead and have our columns in blue and run our prediction on there too. And you can see they overlap the two graphs. So we have our test revenue and our prediction. And then finally, what I started with is we'll go ahead and plot the prediction fully on the bottom and run that. And if you look over here on the graph, we put the blue lines over the red lines. And so you'll see a couple spots where there's red underneath there, but for the most part, our prediction's pretty right on. So it looks really tight. It looks like a good set of predictions for what we're working on. And this is what we were looking at the slide right before we started diving into the RStudio. We can see in the slide here, here's a red. This is a little bit better spread out than what I have on my screen from my RStudio. And the graph shows the predicted revenue. We see that the two lines are very close. So again, they're tight. It's right on. This is what we're looking for in our prediction model. But it's not good enough just having a graph. You always do both. And the reason we do both is you want to have a visual of it, because sometimes you look at these and you get to the graph, you're like, oh my gosh, what is that? And then sometimes you look at the graph and go, that's right on. How come my accuracy doesn't look right? And you realize that your accuracy might be off, or you're plotting it incorrectly. So let's go ahead and look at the accuracy. And we'll use RMSE. That's going to be the variable name we're going to give it. And SQRT, the square root of the mean, and mean just means average. And then we want prediction minus sales revenue, and then we're going to take this whole thing and we're going to square it. So what we've got here is we're going to go through, and let's just explain this formula we're using. Is I'm going to look at what I predict it for to be and what the actual sales, what's our prediction versus our sales, in comparison to the revenue. And when we compare those two, we're going to find the average and then we're going to square each one of those values, and then we're going to average the square and then find the square root of that. And that's quite a mouthful. The reason we do it this way, the reason we square the value and then we find the means, is to generate an answer based on, doesn't matter whether it's plus or minus. There's a lot of other formulas you can use there to check your accuracy and all kinds of other things you can do. But a quick, straightforward way of doing it is just like this, and then let's go ahead and run this. And then we type in the RMSE, and that'll give us an actual printed value out. Let's just see what that looks like. And so we have 866.6338 for our accuracy. And so we look at
what is logistic regression. Let's say we have to build a predictive model or a machine learning model to predict whether the passengers of the Titanic ship have survived or not, the shipwreck. So how do we do that? So we use logistic regression to build a model for this. How do we use logistic regression? So we have the information about the passengers, their ID, whether they have survived or not, their class and name and so on and so forth. And we use this information where we already know whether the person has survived or not. That is the labeled information. And we help the system to train based on this information, based on this labeled data. This is known as labeled data. And during the process of building the model, we probably will remove some of the non-essential parameters or attributes here. We only take those attributes which are really required to make these predictions. And once we train the model, we run new data through it, whereby the model will predict whether the passenger has survived or not. Let's start with what is supervised learning. Supervised learning is one of the two main types of machine learning methods. Here we use what is known as labeled data to help the system learn. This is very similar to how we human beings learn. So let's say you want to teach a child to recognize an apple. How do we do that? We never tell the child, okay, this is an apple has a certain diameter on the top, a certain diameter at the bottom, and this has a certain RGB color. No, we just show an apple to the child and tell the child this is apple. And then next time when we show an apple, child immediately recognizes, yes, this is an apple. Supervised learning works very similar on the similar lines. So where does logistic regression fit into the overall machine learning process? Machine learning is divided into two types, mainly two types. There is a third one called reinforcement learning, but we will not talk about that right now. So one is supervised learning and the other is unsupervised learning. Unsupervised learning uses techniques like clustering and association, and supervised learning uses techniques like classification and regression. Now, supervised learning is used when you have labeled data. You have historical data, then you use supervised learning. When you don't have labeled data, then you used unsupervised learning. In supervised learning, there are two types of techniques that are used, classification and regression, based on what is the kind of problem we are solving. Let's say we want to take the data and classify it. It could be binary classification, like a 0 or a 1. An example of classification we have just seen, whether the passenger has survived or not survived. It's like a 0 or 1. That is known as binary classification. Regression, on the other hand, is you need to predict a value, what is known as a continuous value. Classification is for discrete values. Regression is for continuous values. Let's say you want to predict the share price, or you want to predict the temperature that will be there. What will be the temperature tomorrow? That is where you use regression. Whereas classification are discrete values. Will the customer buy the product or will not buy the product? Will you get a promotion or you will not get a promotion? I hope you're getting the idea. Or it could be multi-class classification as well. Let's say you want to build an image classification model. So the image classification model would take an image as an input and classify into multiple classes, whether this image is of a cat or a dog or an elephant or a tiger. So there are multiple classes, so not necessarily binary classification. So that is known as multi-class classification. So we are going to focus on classification because logistic regression is one of the algorithms used for classification. Now, the name may be a little confusing. In fact, whenever people come across logistic regression, it always causes confusion because the name has regression in it, but we are actually using this for performing classification. Okay, so yes, it is logistic regression.
but it is used for classification. And in case you are wondering, is there something similar for regression? Yes. For regression, we have linear regression. Keep that in mind. So linear regression is used for regression. Logistic regression is used for classification. So in this video, we are going to focus on supervised learning, and within supervised learning, we are going to focus on classification, and then within classification, we are going to focus on logistic regression algorithm. So first of all, classification. So what are the various algorithms available for performing classification? The first one is decision tree. There are of course multiple algorithms, but here we will talk about a few. Decision trees are quite popular and very easy to understand, and therefore they are used for classification. Then we have k-nearest neighbors. This is another algorithm for performing classification. And then there is logistic regression, and this is what we are going to focus on in this video, and we are going to go into a little bit of details about logistic regression.
If you are an aspiring AI ML engineer, then there is no better time to train yourself in the exciting field of AI. If you are looking for a course that covers everything from fundamental to advanced techniques, then accelerate your career in AI and ML with our comprehensive postgraduate program in AI and machine learning. So why wait? Enroll now and unlock exciting AI ML opportunities. The link is in the description box below.
Face detection system. It is a form of biometric recognition, a method for identifying or confirming someone's identity by glancing at their face is called facial recognition. People can be identified by securing a match on facial ID using this technique. Real-time visuals, videos and photos can be the sources to run face detection. This technology is mostly employed in security and law enforcement. OpenCV is the best technology to create it. A Python package called OpenCV is made specifically to address computer vision jobs. Computer vision is a process used in the processing of images by computers. It is concerned with the in-depth comprehension of digital photos or films. It is necessary to automate operations that can be performed by human visual systems. Therefore, a computer should be able to identify items like a statue or a lamppost or even the face of a human being. Second one is chatbot. It is the best idea if you have chosen chatbot as your project topic. This will make your resume more attractive in case you are looking for a job. An Oracle survey suggests that 80% of the businesses uses chatbot. You can use Python, Java, Ruby, C++ or PHP as a programming language to develop a chatbot. Designing and building NLP chatbots that accept speech and text data is made easier by Dialogflow. You can go through many projects to get the rough idea. There are many platforms which will help you to build a chatbot. Regardless of how excellent your chatbot is, there is always room for development. The finest chatbot developers constantly enhance their bots over the time using AI and machine learning.
Social media recommendation system. The rise of web services like Netflix, Amazon and YouTube has increased the use of recommender systems in our daily lives. They are algorithms that assist users in finding information that is pertinent to them. Recommender systems are important in some firms since they can generate a lot of income or allow you to set yourself apart from rivals. In order to provide recommendations, it evaluates the relationship between the user and the object as well as the parallels between users and positions. Coming to predicting stock, this application is widely applicable everywhere. As AI career aspirants, one will love to develop stock prediction applications as it is full of data. This project would be ideal for students who want to work in the finance industry because it can provide them a better understanding of various aspects of the field. Coming to medical diagnosis, this project is advantageous from a medical standpoint. AI projects can be created to detect heart-based diseases and also detect cancer. It is intended to offer patients with heart illness online medical advice and guidance. After processing the data, this system will search the database for any illnesses that might be connected to the given details. Using data mining techniques, this intelligent system determines the disease that that the patient's information most closely resembles. Based on the system diagnosis, users can then speak with qualified medical professionals. Users of the system can also view information about various doctors. Coming to an important project, that is search engine. Search engines are utilized by all. We look for information on the greatest product to buy, a nice area to hang out, or solutions to any questions we have. NLP is quite significant in modern search engines because a lot of language processing takes place there. Python is the widely used language to develop any search engine. Search engine is mainly confined with lots and lots of data. It is helpful for any AI career aspirants. Next is virtual assistants. Here the challenge is to build a virtual assistant to assist user. Why do you need virtual assistant in your devices when you are building your own? It is also interesting for a ML developer to build a virtual assistant. It involves NLP and data mining. Voice-based virtual assistants are popular today because they make life easier for users. NLP is utilized to comprehend human language in order to construct this system. When a voice command is received, the system will translate it into machine language and store the commands in its database. Hate speech detection in social media. Automated hate speech detection is a crucial weapon in the fight against hate speech propagation, especially on social media. For the job, many techniques have been developed, including a recent explosion of deep learning based system. For the objective of detecting hate speech, a number of techniques have been investigated, including conventional classifiers, classifiers based on deep learning, and combination of both of them. On the other hand, a number of dataset benchmarks, including Twitter sentiment analysis, have been introduced and made available for the evaluation of the performance of these algorithms. And the last one is predicting house price. You will need to estimate the sale price of a brand new home in any place for this assignment. The dataset for this project includes information on the cost of homes in various city neighborhoods. The UCI machine learning repository is the place where you may find the dataset needed for this research. You will also receive other dataset with information on the age of the population, the city's crime rate, and the location of non-retail enterprises in addition to the pricing of various residences. It's an excellent project to test your knowledge if you are a newbie.
Popular market research projects that the market for artificial intelligence will grow from $59.7 billion in 2021 to $422.4 billion in 2028. Artificial intelligence, automation, and robotics are disrupting almost every business. Companies that don't invest in AI services risk becoming obsolete, whether in machine learning, smart applications, appliance, digital assistants, or autonomous vehicles. Numerous companies stand to benefit from AI, but a handful of them have proven to be the game changers for 2023 and beyond. So hey everyone, you are already watching Simplilearn, and here we are with the list of top 10 AI companies in 2023. If you love watching videos like these, do hit the subscribe button to never miss an update from Simplilearn. So let's explore and learn about them one by one, starting with the 10th position, which is UiPath. Robotic Process Automation, or RPA, is a technology developed by UiPath that helps businesses to boost productivity and reduce cost by automating time-consuming and repetitive operations. Software robots can be equipped with UiPath AI technologies to carry out duties including reading documents and emails, interpreting language and visual cues, and comprehending the content and the intent of the communications. The RPA market is estimated to be worth $38 billion, and UiPath offers distinct advantages over the competitors, thanks to its patent computer vision technology and wide range of bot technologies. In the 9th position, we have Dynatrace. The services offered by Dynatrace include observability and infrastructure monitoring. The Davis AI engine developed by the business can analyze 368 trillion dependencies each second. Davis can quickly locate problems in a company's digital ecosystem, explain what went wrong, and evaluate and rate likely commercial ramifications. The company estimated a market worth $285.42 million and is poised to grow revenue by roughly 20% annually throughout at least 2025. Then at the 8th position, we have Palantir Technologies. Data analytics software startup Palantir Technologies uses AI to analyze data. According to revenue and market share, Palantir was ranked as the top AI software platform globally by IDC in September 2022. The United States intelligence and defense industries account for a sizable portion of Palantir's revenue. The business just won a new $85.1 million contract from the US Army Marshall Command to assist with the developing AI and machine learning technologies to enhance equipment reliability, improve predictive maintenance, and improve supply chains. Palantir may deliver revenues closer to the higher end of analysis estimates, roughly $2.5 billion in 2023. Then, at the 7th position is Workday. Workday is a provider of cloud-based applications with an emphasis on human resources management. With the assistance of Workday's distinctive AI-based optimization engine, businesses can manage challenges with hiring and staffing, fluctuation labor demand, shift scheduling and prioritizing, and more. In April 2022, Workday incorporated Barista, an AI-powered virtual assistant from Espressive, into their platform. Workday is raising 2023 market worth to almost $5.53 billion, representing year-over-year growth of 22%. Now in the 6th position, we have Intuitive Surgical. The Da Vinci surgical system offered by Intuitive Surgical performs minimally invasive procedures using cutting-edge robots and computerized visualization technology. With the help of a big data and AI, Intuitive is developing tools that will help surgeons by improving their training and offering them real-time direction. Despite the fact that the Da Vinci surgical system has been approved by US FDA for 22 years, Intuitive reported a 13% year-over-year increase is installed in the system most recent quarter. The global intuitive surgical market is projected to reach $6.5 billion by 2023. Moving towards the 5th position, we have IBM. For years, IBM has been developing strategies to use its AI supercomputer to alter the legal, banking, academic, and healthcare industries. IBM's clients harness the power of AI to stay current on ever-changing regulations by providing end-to-end risk and compliance management. IBM continues to dominate the market for the other breakthroughs in AI, and its Auto AI and Auto ML products can help data scientists build and improve AI and machine learning models. The market worth of IBM in 2023 will range from $14.4 billion to $16 billion. Following that, in the 4th position is NVIDIA. High-end chip maker NVIDIA provides the significant computing power needed for advanced AI applications. In reality, one of the world's fastest supercomputers, Leonardo, is powered by NVIDIA graphics processing units. The parent company of Facebook, Meta Platforms, is building the biggest artificial intelligence supercomputer in the world. Meta also owns NVIDIA's Quantum InfiniBand networking system and 6080A 100 NVDA graphics processing processors. NVIDIA is a significant supplier for fast-growing industries like high-end gaming, business graphics, cloud computing, artificial intelligence, and advanced automotive technology. NVIDIA's outlook for 2023 revenue is expected to be around $6 billion. Here comes the top 3 in the list, and in the 3rd position, we have Amazon. AI is integrated into every aspect of Amazon's business, including e-commerce, search engines, targeted advertising, and Amazon Web Services. Amazon Alexa, one of the most popular virtual assistants, is already present in many American homes. Amazon said in August that it would pay $1.7 billion to acquire Robots Corp (RBT), a maker of home robots. This action can allow Amazon to boost the use of AI in households worldwide. Amazon expects a $491 billion market worth between 2023 and 2027. In the 2nd position is Alphabet. Alphabet, the company that owns Google and YouTube, uses AI and automation in practically every part of its business, including ad pricing, Gmail spam filters, and content promotion. In addition, it is the parent company of the autonomous car manufacturer Waymo and the AI software business DeepMind, which created history in 2022 when it became the first completely autonomous commercial taxi service to operate on public roads. The market worth of Alphabet in 2023 will be around $70 billion, and the 1st position on the list is Microsoft. In 2020, Microsoft announced the construction of a new supercomputer hosted on Azure, Microsoft's cloud computing network. The supercomputer was created in collaboration with OpenAI to train AI models, producing substantial AI models and related infrastructure for programmers and other businesses. In October, Microsoft released Microsoft Designer, a graphic design tool that makes original social media posts, invitations, and other graphics using AI technology. Microsoft, the tech giant, is expected to earn a market worth of $49.73 billion. And with that, we have come to the end of this list of the top 10 artificial intelligence companies of 2023.
Opportunities in AI have increased significantly in recent years. The surge in jobs related to AI is legitimate due to its widespread involvement in crucial fields. According to Indeed, the pay range for jobs involving artificial intelligence is between $160,000 to $350,000 and can go even higher. So we have come up with a list of leading career opportunities in artificial intelligence along with companies hiring for those roles. But before we begin, here is a question for you. Who do you think is currently leading the AI market? Let us know in the comment section below. So without any further delay, let's get started. Starting with our list, we have robotics engineer. An engineer in robotics creates prototypes, constructs and tests machines and updates the software that manages them. Additionally, they investigate the most affordable and secure way to make their robotic system. Aspirants should have a bachelor degree in computer science and pursue a career in robotics with additional training or certification in automation is advantageous. Robotics engineers are in high demand with 9,000 plus job openings in India and 8,000 plus openings in the US. Top companies like Amazon, Bosch and Flybase are hiring robotics engineers with salaries as high as $160,000 in the US and rupees 27 lakhs in India. Next up on our list, we have product manager. The role of a product manager is to recognize and express user requirements, market research, and creating competitive evaluations. And also creating a product's vision and putting emphasis on a product's strengths and qualities. Freshers cannot join as a product manager. It requires basic experience of 2 to 3 years in the field of product and software development. According to Indeed.com, an average of 2,000 plus jobs are currently available in India and 20,000 plus job vacancies are there in the US, with top companies hiring are Tesla, Amazon, TCS, Sprinkler, Cognizant, etc. with a salary as high as $160,000 per year in the US and rupees 20 lakhs per annum in India. Up next we have data scientists. They mainly deal with lots of data. Extraction of knowledge from all collected data is the subject matter of a data science. It was also voted the sexiest job of the 21st century. Good news is there is no need for any special degree. As a data scientist, you need to have knowledge of machine learning, programming in Python, R, Java, and mathematical modeling. Being a fresher, you can join as a data scientist too. Data scientists are in demand with 17,000 plus vacancies in the US and 3,000 plus vacancies in India, and big businesses like Accenture, TCS, IBM, Google, JP Morgan, Deloitte, Bank of America recruiting data employees with salary going as high as $200,000 per year in the US and rupees 15 lakhs per annum in India. Moving forward in our list, we have AI data analyst. Data mining, data cleaning, data interpretation are the three main tasks of an AI data analyst. Data cleaning allows for the gathering of the necessary information for data analysis. An AI data analyst makes inferences from the data using statistical tools and techniques. You need a bachelor degree in computer science or mathematics to work as an AI data analyst. To get this job, you must have a thorough understanding of regression and be able to use MS Excel. According to Indeed.com, there are currently 700 plus AI data analyst jobs available in the United States and 16,000 plus job vacancies in India, with top companies like Accenture, IBM, Wipro, TCS and Capgemini recruiting them and salaries going as high as $100,000 per year in the US and rupees 8.5 lakhs per annum in India. The next job opportunity in AI is Business Intelligence Engineer. A business intelligence developer's main duty is to take both business sense and AI into account. They evaluate complex data sets to identify various business trends. They assist in boosting a company's earnings by planning, creating and sustaining business intelligence solutions. To become a business intelligence engineer, you are required to have a bachelor degree in mathematics and computer science. According to Indeed.com, there are 8,000 plus jobs available in India and 5,000 plus job vacancies in United States. Companies hiring are Amazon Development Center, IBM, AWS, etc. With this, salary going as high as $100,000 per year in the USA and rupees 15 lakhs per year in India. Coming to the top 3 jobs available in AI, at number 3, we have machine learning engineer. Artificial intelligence is known to include machine learning. It runs simulations using the varied data provided and produces precise results. They are constantly in demand from the businesses and their position seldom goes unfilled. They handle enormous amount of data and have exceptional data management skills. The ability to code, use computers, and understand mathematics are requirement for success as a machine learning engineer. A master's degree in computer science or mathematics is highly preferred. The necessary technological stacks include Python, R, Scala, and Java. A deep understanding of neural networks, deep learning, and machine learning algorithm is very helpful. Coming to job opportunities, Glassdoor.com predicts 13,000 plus job vacancies in the US and 27,000 plus jobs available in India, with companies like MathWork, Google, Amazon, Microsoft Azure, IBM, etc. hiring them with salary going as high as 150,000 per annum in the US and rupees 10 lakhs per annum in India. Coming at runner-up position, we have data architect. Data architects are IT specialists who utilize their knowledge of computer science and database architecture to assess and analyze an organization's data infrastructure. Fresher graduates cannot become data architects. A bachelor degree in computer science and computer engineering or related subject is the absolute minimum requirement to become a data architect. Data architects are in high demand with 52,000 job vacancies in the United States and 7,000 plus jobs in India, and top companies hiring data architects are Amazon, IBM, Tesla, Intel, Wipro, with the average salary quite high as $200,000 per year in the United States and rupees 21 lakhs per annum in India. And topping our list of job opportunities in AI is AI engineer. AI engineers are problem solvers who create, test and use various artificial intelligence models. They manage the AI infrastructure well. To create practical AI models, they use neural network knowledge and machine learning methods. These models enable one to gain business insights, which aids the organization in making wise business decisions. UG or PG degree in the field of AI or computer science is required. In addition to that, you can hold certifications from any reputed organization, which will add up to your resume. Please check out and enroll to the AI program by Simplilearn in collaboration with Purdue University. The link is provided in the description below. Job openings for an AI engineer are quite high, with 35,000 plus job vacancies in the US and 4,000 plus jobs in India, and tech giants like Accenture, TCS, IBM, Google, JP Morgan, Deloitte, Bank of America recruiting them with salary going as high as $200,000 per year in the US and rupees 10 lakhs per annum in India.
The term generative AI has emerged seemingly out of nowhere in recent months, with a notable surge in interest according to Google Trends even within the past year. The spike in curiosity can be attributed to the introduction of generative models such as DALL-E 2, BARD, and ChatGPT. However, what does generative AI entail? As a part of our introductory series on generative AI, this video will provide a comprehensive overview of a subject starting from the basics. The explanation will cater to all levels of familiarity, ensuring that viewers gain a better understanding of how this technology operates and its growing integration to our daily lives. Generative AI is, after all, a tool that is based on artificial intelligence. A professional who seeks to switch careers with AI by learning from the experts. Then try giving a short Simplilearn postgraduate program in AI and machine learning from Purdue University in collaboration with IBM. The link in the description box should navigate to the home page where you can find a complete overview of the program being offered. Take action, upskill and get ahead. What is generative AI? Generative AI is a form of artificial intelligence possesses the capability of to generate a wide range of content including text, visual, audio and synthetic data. The recent excitement surrounding generative AI stems from the user-friendly interfaces that allow users to effortlessly create high-quality text, graphics, and video within a seconds. Now moving forward, let's see how does generative AI works. Generative AI begin a prompt which can take form of text, image, video, design, audio, musical notes, or any input that AI system can process. Various AI algorithms that generate new content in response to the given prompt. This content can range from essay and problem solution to realistic created using images or audio of a person. In the early stages of generative AI, utilizing the technology involved submitting data through an API or a complex process. Developers need to acquaint themselves with a specialized tool and writing application using programming language like Python. Some of the recent and fully operational generative AIs are Google Bard, DALL-E, OpenAI ChatGPT, Microsoft Bing, and many more. So now let's discuss ChatGPT, DALL-E, and Bard, which are the most popular generative AI interfaces. So first is DALL-E 2, which was developed using OpenAI GPT implementation in 2021. Exemplify a multimodal AI application. It has been trained on a vast dataset of images and their corresponding textual description. DALL-E is capable of establishing connection between various media forms such as vision, text, audio. It specifically links the meaning of words to visual elements. OpenAI introduced an enhanced version called DALL-E 2 in 2022, which empowers users to generate imagery in multiple styles based on their prompts. And the next one is ChatGPT. In November 2022, ChatGPT, an AI-powered chatbot built on OpenAI GPT 3.5 implementation, gained immense popularity worldwide. OpenAI enabled users to interact with and fine-tune the chatbot's text response through a chat interface with interactive feedback, unlike earlier version of GPT that was solely accessible via an API. ChatGPT brought a more interactive experience. On March 14, 2023, OpenAI released GPT-4. ChatGPT integrates the conversational history with a user, making a genuine dialogue. Microsoft, impressed by the success of new ChatGPT interface, announced a substantial investment in OpenAI and integrated a version of GPT into its Bing search engine. And the next one is Bard, Google Bard. Google was also an earlier forerunner in advancing transformer AI techniques for language processing, protein analysis, and other content types. It made some of these models open source for researchers but were not made available through a public interface. In response to Microsoft's integration of GPT into Bing, Google hurriedly launched a public-facing chatbot named Google Bard. Bard's debut was met by an error when the language model incorrectly claimed that the Webb telescope was the first to discover a planet in a foreign solar system. As a consequence, Google's stock price suffered a significant decline. Meanwhile, Microsoft's implementation of ChatGPT and GPT-powered system also faced criticism for producing inaccurate results and displaying erratic behavior in their early iteration. So, moving forward, let's see what are the use cases of generative AI. Generative AI has broad applicability and can be employed across a wide range of use cases to generate diverse forms of content. Recent advancements like GPT have made this technology more accessible and customizable for various applications. Some notable use cases for generative AI are as follows. Chatbot implementation. Generative AI can be utilized to develop chatbots for customer service and technical support, enhancing interaction with users and providing efficient assistance. The second one is language dubbing enhancement. In the realm of movies and educational content, generative AI can contribute to improving dubbing in different languages, ensuring accurate and high quality translation. And the third one is content writing. Generative AI can assist in writing email responses, dating profiles, resumes, and term papers, offering valuable support and generating customized content tailored to specific requirements. And the fourth one is art generation. Leveraging generative AI, artists can create photorealistic artwork in various styles, enabling the exploration of new artistic expression and enhancing creativity. The fifth one is product demonstration videos. Generative AI can enhance product demonstration video, making them more engaging, visually appealing, and effective in showcasing product features and benefits. So generative AI versatility allows it to employed in many other applications, making it a valuable tool for content creation and enhancing user experience across diverse domains. So after seeing use cases of generative AI, let's see what are the benefits of generative AI. So generative AI offers extensive application across various business domains, simplifying the interpretation and comprehension of existing content while also enabling the automated creation of a new content. Developers are actively exploring ways to leverage generative AI in order to enhance the optimize existing workflows and even to reshape workflows entirely to harness the potential of technology fully. Implementing generative AI can bring numerous benefits, including Automated content creation. Generative AI can automate the manual process of writing content, saving time and effort by generating text or other form of content. The next one is efficient email response. Responding to emails can be made more efficient with generative AI, reducing the effort required and improving response time. And the third one is enhanced technical support. Generative AI can improve responses to specific technical queries, providing accurate and helpful information to users or customers. And the fourth one is realistic person generation. By leveraging generative AI, it becomes possible to create realistic representation of people, enabling applications like virtual characters or avatars. And the fifth one is coherent information summarization. Generative AI can summarize complex information into a coherent narrative, distilling key points and making it easier to understand and communicate complex concepts. The implementation of generative AI offers a range of potential benefits, streamlining process and enhancing content creation in various areas of business operation. So after seeing advantages of generative AI, let's move forward and see what are the limitations of generative AI. Early implementation of generative AI serve as vivid examples highlighting the numerous limitations associated with this technology. Several challenges arise from the specific approaches employed to implement various use cases. For instance, while a summary of a complex topic may be more reader-friendly than explanation incorporating multiple supporting sources, the ease of readability comes at the expense of transparent identifying the information sources. So the first one is, when implementing or utilizing a generative AI application, it is important to consider the following limitation. I repeat, the first one is lack of source identification. Generative AI does not always provide clear identification of content source, making it difficult to trace and verify origin of the information. The second one is assessment of bias. Assessing the bias of original sources used generative AI can be challenging, as it may be difficult to determine the underlying perspective or agenda of the data utilized in the training process. The third one is difficulty in identifying inaccurate information. Generative AI can generate realistic content, making identifying inaccuracy or falsehoods within the generated output harder. And the fourth one is adaptability to a new circumstances. Understanding how to fine-tune generative AI for a new circumstances or specific context can be complex, requiring careful consideration and expertise to achieve desired result. And the fifth one is glossing over bias, prejudice and hatred. Generative AI results may amplify or perpetuate biases, prejudices or hateful content present in the training data, requiring vigilant scrutiny to prevent such issues. So awareness of these limitations is crucial when implementing or utilizing generative AI, as it helps users and developers critically evaluate and mitigate potential risks and challenges associated with the technology. So, future of generative AI. Furthermore, advances in AI development platforms will contribute to the accelerated progress of research and development in the realm of generative AI. The development will encompass various domains such as text, images, videos, 3D content, drugs, supply chains, logistic and business processes. While the current standalone tools are impressive, the true transformative impact generative AI will realize while these capabilities are seemingly integrated into the existing tools with regular use.
Hello and welcome to this video on Edge AI for Artificial Intelligence. If you're interested in learning more about how AI is revolutionizing the world around us, this video is for you. Edge AI is a new concept in the world of AI that refers to devices and sensors at the edge of the network that can collect and process data in real time. This allows for faster, more accurate decision-making and greater efficiency in a variety of applications, such as self-driving vehicles, smart homes, and health monitoring. So, how is Edge AI different from cloud computing and cloud computing AI? The main difference is the location where the data is processed. Edge AI enables devices at the edge of the network to process data locally without having to send it to the cloud. This can lead to faster, more responsive systems and can help you preserve bandwidth and reduce latency. In contrast, cloud computing AI processes data in the cloud, where it can access vast amount of data and compute resources, but also requires a reliable internet connection and can be slower. As Edge AI becomes more advanced, it has the potential to transform many industries, such as healthcare, transportation, manufacturing, and a lot more. It can enable new applications such as autonomous vehicles, remote surgery, and real-time monitoring of machines and equipments. While cloud computing AI has many benefits, Edge AI offers the advantages of faster decision making, reduced latency, and improved efficiency. So, if you're interested in learning more about the future of AI, Edge AI is definitely a topic worth exploring. On that note, hello everyone and welcome to Simplilearn. In today's video, we'll understand what edge computing is and how it is different from traditional cloud computing. But before we begin, make sure to subscribe to our channel to stay updated with all the latest technologies and hit that bell icon to never miss any updates from us.
So without any further ado, let's jump directly into our today's topic. So firstly, let us understand what is edge computing. The term edge computing for AI refers to the process of running AI computations and processing close to the data source or edge devices at the edge of a network, as opposed to relying on centralized cloud-based servers. In order to enable real-time data analysis, quicker response times, and a decreased reliance on cloud infrastructure, it deploys AI models and algorithms directly on edge devices or local servers. AI edge computing typically entails the deployment of lightweight AI models designed to use on edge devices with constrained computational power. Then these models are frequently deployed to the edge after being trained using cloud-based resources. The edge devices gather data from their sensors or from outside sources, process the data locally using the AI models that have been deployed, and give prompt responses or start processes based on the data. But what led to the rise of edge AI? Well, with rapid advancement in technology in every sector, and businesses are looking to increase automation to increase workflow, productivity, and security, and for that, computer programs must be able to identify patterns and carry out tasks repeatedly and safely in order to assist people. Now, the range of tasks that humans perform, however, covers infinite situations that are impossible to fully describe in codes and rules because the world is very unstructured. Well, with the help of developments in edge AI, machines and gadgets can now function with the intelligence of human cognition wherever they may be. Smart applications with AI capabilities can learn to carry out the same tasks under various conditions, just like in real life. And here are the three recent innovations that explain why using AI models at the edge is on the rise. Well, first on the list, we have advancement of neural networks. Now, over the years, as you know, neural networks and related AI infrastructure have advanced and matured, allowing for more generalized machine learning capabilities. This means organizations have to gain a deeper understanding on how to train AI models effectively and deploy them in production at the edge. Development in computational infrastructure. Now, running AI at the edge requires substantial computational power. The field has witnessed notable advancements in computational infrastructure to support AI at the edge. Particularly, recent strides in highly parallel graphic processing units or GPUs and CPUs have enabled efficient execution of neural networks. GPUs are specifically designed to handle complex parallel computation, making them a suitable choice for processing AI workloads. And finally, widespread usage of IoT devices. Now, the widespread adoption of Internet of Things devices has generated vast amounts of data. These devices, such as industrial sensors, smart cameras, and robotics, provide a rich source of data that can be utilized for AI analysis at the edge. The availability of diverse IoT devices and their ability to capture real-time data has facilitated the deployment of AI models at the edge. But why deploy AI at the edge? What are the benefits of edge computing? Now, edge computing for AI addresses the limitations and challenges associated with conventional cloud-centric AI methods. So here are some of the advantages which it offers. Firstly, decreased latency. Now, by performing AI processing at the edge, there is a significant reduction in network latency since data no longer needs to be transmitted to the cloud and back. This is particularly beneficial for applications that demand real-time responses or decision-making, let's say like autonomous vehicles or industrial automation. Secondly, real-time data analysis. Edge computing for AI enables immediate data analysis and inference directly on the edge devices themselves. This is especially valuable for time-sensitive applications that require real-time insights or predictions, eliminating the need for reliance on cloud connectivity. Enhanced privacy and security. Well, edge computing enhances privacy and security by keeping data and AI processing local. Sensitive information can be processed on the edge devices without being transmitted to the cloud, minimizing the risk of data breaches and ensuring compliance with data privacy regulations. Next, we have bandwidth optimization. Edge computing reduces the volume of data that needs to be transmitted to the cloud, sending only relevant or let's say summarized data. Now, this optimization minimizes bandwidth requirements, reduces network cost, and even lightens the load on the cloud infrastructure in total. And finally, it offers offline functionality. Edge computing enables AI models to function even in situations with limited or no internet connectivity. This capability is crucial for scenarios that require continuous operation in remote or disconnected environments, such as certain IoT applications or field deployments. So these were some of the reasons why we need to deploy AI at the edge and the benefit it's offering. Now comes the main question. How exactly does edge computing works? Well, edge computing is primarily focused on the proximity and location of data processing and storage. The fundamental principle is simple. When it's not feasible to bring data to a centralized data center, the alternative is to bring the data center close to the data. Now, in order to enable machines to perform tasks like, let's say, visual perception, object detection, driving cars, understanding speech, speaking, walking, and emulating other human skills, they need to replicate human intelligence in a functional manner. So for that, AI uses a deep neural network as a data structure to emulate human cognition. These DNNs undergo training in data centers and are exposed to numerous examples of specific task or question type along with their correct answer. And once the training is complete, the model advances to become an inference engine capable of addressing real-world questions. Now from there on, here's how it typically works. Firstly, deployment of inference engine. Now, in edge AI deployments, the inference engine, which is the component responsible for making predictions or performing AI tasks, is deployed on local computers or devices located in diverse environments like factories, hospitals, cars, satellites, homes, and much more. Problem identification and data upload. Now, while the inference engine operates at the edge, it may encounter a situation where it struggles to provide accurate predictions or encounter challenging scenarios. In such cases, the problematic data associated with these instances is commonly identified and uploaded to a centralized cloud structure. Now, from there on, there is a continuous cloud-based model training. Now, the cloud infrastructure typically in a data center receives the problematic data from edge devices. Data scientists and AI experts can then utilize this data to refine and train the original AI models further. This involves using the cloud's computational resources, larger data sets, and collaboration tools for model training and improvement. Now, and finally, with the updated model deployed at the edge after being retrained, the AI system continues to operate, gaining new data and insights from its environment. The edge AI model can collect further additional data, which can be periodically uploaded to the cloud and further training and continuous improvement. This feedback loops ensures that the edge AI models become progressively smarter over time. So this is in a nutshell how edge computing for AI works. Hope you have understood. Well, let us talk some of the use cases of edge computing for AI in real world. Well, the combination of AI, IoT, and edge computing has opened up a multitude of opportunities for edge AI, revolutionizing the various aspects of our daily lives. So let's delve into some key areas where edge AI is making a significant impact. First on the list, we have healthcare. Edge AI is enhancing medical diagnostics and patient care. For instance, by deploying AI edge algorithms on medical imaging devices, radiologists can accurately and efficiently identify and analyze pathologies. Wearable devices with local edge analytics enable real-time monitoring of patient data, facilitating any early detection of anomalies and timely interventions. Next, autonomous vehicles. Edge AI plays a pivotal role in enabling real-time navigation and decision-making for autonomous vehicles. AI algorithms running on edge devices within vehicles process sensor data, analyze the environment, and make split-second decisions to ensure safe and efficient driving. Agriculture. Edge AI is being used to address agriculture challenges as well, such as pollination. Autonomous drones equipped with edge AI capabilities can identify and pollinate plants, aiding in crop cultivation and maximizing yields. This application demonstrates the diverse potential of edge AI beyond traditional domains. Next, we have smart home and cities. Now, edge AI enhances the functionality and efficiency of smart homes and cities. Local processing and analysis of data from IoT devices enable real-time automation, energy management, security surveillance, and personalized user experience. Edge AI-powered systems adapt to individual preferences, optimize resources usage, and respond to events in real time. Next, we have industrial applications. Edge AI is transforming industries thoroughly through real-time monitoring, predictive maintenance, and process optimization. Edge devices equipped with AI algorithms analyze sensor data, detect anomalies, and predict equipment failures, reducing downtime and improving efficiency. Next, we have security and surveillance. Well, Edge AI plays a crucial role in security and surveillance, which empowers real-time video analytics for security and surveillance applications. Edge devices with AI capabilities can analyze video feeds locally, detect suspicious activities like theft, identify objects or individuals of interest, and trigger alerts or responses, enhancing security measures and reducing response times. And finally, we have personal devices. Edge AI is increasingly being integrated into personal devices such as your smartphones, laptops, wearables, and smart home assistants. This allows for on-device AI processing, enabling faster and more personalized experience without relying heavily on cloud connectivity, which can support voice recognition, facial recognition, among other features as well. Well, as more businesses and industries recognize the advantage of Edge AI, its adoption is rapidly growing. The ability to process data locally, enhance privacy, reduce latency, and make real-time decisions empowers organizations in various sectors to enhance operations, deliver better services, and improve user experience. So these were some of the real-time applications of Edge AI. And with that, we've come to the end of today's session on what edge computing for AI is.
In this video, we are going to take you through an interesting AI tool which can help you in different ways. The Flare AI we are going to discuss, and this AI can help you create your own advertisement. I mean, if you own a product or if you want to advertise something, then this tool is the go-to option for you, and we are going to see how to use this tool in this particular video. But before we begin, if you enjoy watching these videos and if you find them interesting, then subscribe to Simplilearn's YouTube channel because we bring the best videos for you daily. Also hit the bell icon to never miss any updates from Simplilearn. We all know that AI is expanding at a very rapid pace. ChatGPT is a great example. So in this time, bagging a job in this field is super beneficial because of course it offers great salary packages and AI is interesting, as we all know. So on that note, we present to you the Simplilearn's postgraduate program in AI and machine learning in collaboration with Purdue University. Boost your career with this AI and ML course delivered in collaboration with Purdue University and IBM. You can learn in-demand skills such as machine learning, deep learning, NLP, computer vision, reinforcement learning, generative AI, prompt engineering, ChatGPT, and many more. You'll receive a prestigious certificate and Ask Me Anything session by IBM. With 5 capstones in different domains using real data sets, you will gain practical experience as well. Masterclasses by Purdue faculty and IBM experts ensure top-notch education. Simplilearn's Job Assist helps you get noticed by leading companies. So this program covers statistics, Python, supervised and unsupervised learning, NLP, neural networks, computer vision, GANs, Keras, TensorFlow, and many more skills. So enroll now and unlock exciting AI and machine learning opportunities. The link is mentioned in the description box below. So let's begin with Flare AI. What we have to do first is we have to go to Google and just write here Flare AI. Fine. So this is the first option you will get. Click on it, Flare AI. So this is the interface of Flare AI, the AI design tool for branded content. So it can help you with your brand. Definitely you will get better reach because what usually happens is we use different tools like Adobe Photoshop and other tools to just show a brand item in different ways. But with this AI tool, we can use this and it's not time consuming as well. So let's start. What we'll do is we'll write here create with Flare. So here you can see we have a demo video basically. So here you can see we have a product, a perfume bottle, and here we have different items, or we can say different options. We can generate, we can customize, and that's it. Just right here, click generate, it will generate a beautiful image for you. So let's start, or if you want to watch the video, here's the video. So here you can see this image turned into that. So we don't have to do much of editing, everything was done by AI. So let's see how we can do it. So we'll click on create with Flare. Now continue with Google. So you will have to log in. Although it's free to use, this AI tool is completely free. So here we are going to click on create new project. So here you can see we have a box for placing our product here. So let's say we are placing something out of here. Fine. So here you can see we have a Starbucks coffee. Let's place it in the middle. So generated images will appear here. See, here you can see generated images will appear here. It's written. Now click on generate what you want to do. So here you can see we have different templates. Fine. we have this template, we can use this, we can use any of them. So let's use this one. Fine. And click on this, click on generate. So paper cup on a rock surrounded by trees in front of canyon and river. Fine. So here you can see it's still progressing. And now here you can see we have a coffee mug present over here, Starbucks coffee. If I zoom in for you a little bit, so here you can see how nice it's looking. It's not even looking like that this cup is edited. It's looking like that this cup is actually placed there. So another way, if we want to do the same thing, what we have to do is we have to use Adobe Photoshop, we have to use different tools, right? But here you can see how detailed it is. We have shadows for the cup as well. Not just that, but if you click here on generate, and if you will find the mirror one, you will get to see the reflection completely. So if I click here, paper cup on a wet surface surrounded by rain in front of spotlight and strong shadows. So it's pretty good. We'll copy it as well. We'll need it later on. I'll tell you why we'll need it. So here you can see it's good, right? So here you can see, and here you can see we have a image, the paper cup. What it said, paper cup on a wet surface, the surface is wet, surrounded by rain. So here you can see rain in front of a spotlight and strong shadows. In front of spotlight and strong shadows. So here you can see the shadow of a paper cup. Fine. Similarly, we can use different tools. We have different elements as well. Like if you want to use, for example, if you go on humans, if you want to use, we have a hand thing. So here you can see if you want to put it here, and if you want to bring it to the front, so here you can see it's on a hand. So here you can see how we can use this tool. Fine. So we have a number of options available here. If we'll go to assets, so here you can see we have a perfume bottle as well. We'll delete this one. We'll use a perfume bottle. It's from Chanel. And now what we are going to do is we are going to delete them as well. Now what we are going to do is we are going to generate something else. Fine. So now we are going to use the editor. So here you can see we have a product which is a perfume bottle. So we have to edit the prompt in the form below. Fine. The product is a perfume bottle. Then we have a placement where we want to place it on a mirror. Or here you can see we have different options. So let's say we are using wooden surface surrounded by let's say flowers. Fine. Now create this image in your mind. We have a perfume bottle which is present on a wooden surface. Its placement is on a wooden surface and it is surrounded by flowers. Fine. Now number of results, how many number of results you want? I'll make it extra strong, color strength and outline strength, just to show you guys how it looks. Now click on generate and wait for few seconds, not even minutes, but it will be done in few seconds. Here you can see how fast this AI is. So this AI tool is very useful if you have your own brand, if you have your own products, not services but product. So here you can see it's present on a wooden surface and we have flowers on it. Fine. So what we'll do is we'll write here next to orange. Fine. Generate. It totally depends on your creativity, how you want to create your image, how you want to present your brand service or your brand product. So here you can see we are done with almost 85%. We have to wait for few more seconds, not even a minute, as I already mentioned, and it will be done. So here you can see it's present on a wooden surface and the orange is not there. Basically what we have to do is we have to go to generate. We have to use something else then. We'll use almonds. Fine, let's see if it works or not. Perfume bottle on a wooden surface next to almonds in front of spotlight and strong shadow. Okay, we are not going to use this. What we are going to do is nature in the background. Let's see how it looks. Wait for few more seconds and again it will give you an AI generated image which will be present on a wooden surface next to almonds in front of nature in the background. Now here you can see we have a wooden surface, we have almonds present over here, and we have nature behind it. Wow, it looks fine, not that good. So what we'll do next is we'll write here circular glass platform, and we'll write here next to a mug. We are not going to use jungle, we are going to use orange sunset in the background. Maybe it will look better because sunsets are always beautiful. So let's see how it comes out. So here we have the output. So it's present on a circular glass platform. Okay, it's fine. We have a mug. Okay, the mug is not visible, or maybe this is the mug, it's not that good. And then we have the sunset. So sunset is here. Here you can see now the image looks real. That's the point. It's not something that looks like that it's edited or it's just cropped from somewhere and put it over there. No, it looks real. Fine, right? It has the shadows and all the edges and saturation. It's changed as per the background. So right now the background is sunset, so here you can see the orange lights here present over here. Fine. So that's how you can use this tool to create an advertisement for your brand product. Now the next thing is not just that, but it allows you to upload your own pictures. So it's quite interesting. Let me just delete all of them. So what you have to do is you have to download the picture of your product, upload it from here. And we have a product of an iPhone, so here I have this picture. Okay, so I'll skip this for now because I'm going to show you. If I write here, let's say it's an iPhone. Done. Now here you can see we have a product placed here. So here you can see we have a background, right? We have blue and white, this base as well. So the first thing we are going to do is we are going to click on that. We are going to click on edit. Now the best part is we can remove this background, and it turns out to be so good. Let's check it out. So click on remove background. It will take few seconds to remove all this from your background, and you will notice something, that the background, the edges of the phone, how nicely it has done it. So here you can see there's nothing wrong and every edge is perfectly fine, right? The background is completely removed now. Now what we have to do is we have to generate a image. So we have an iPhone, we want it to be presented as circular glass platform. We will golden sparkles in front of. Let's remove it and see what else we have. Desert in the background. Let's try this. Generate it, and it will again take few seconds. So are you guys ready to check out an iPhone present in the desert? So basically the idea of this AI tool is it saves a lot of time for anyone, right? So here you can see the iPhone is present in a circular glass platform, right? And we have, what else we had? Okay, we had golden sparkles. Golden sparkles are here somewhere, and we have a desert in the background. So desert, here you can see we have a desert. Now what we'll do is we'll write here mirror, and we want it to be present in water and droplets. Fine, so let's try it. I haven't tried it either till now, so it will take some time. The iPhone will be placed on water with some droplets surrounding it, and the background will be okay, a mirror. So it looks good, right? So here you can see the shadow, actually the shadow of the phone, how realistic it looks. So this is how you can use this AI tool, and not just that, but you can download your images. So here you can see, click on download image, and done. The image is downloaded. In just click you have from this to this, and it totally depends on your creativity how you want to present your brand product.
If you are an aspiring AI ML engineer, then there is no better time to train yourself in the exciting field of AI. If you are looking for a course that covers everything from fundamental to advanced techniques, then accelerate your career in AI and ML with our comprehensive postgraduate program in AI and machine learning. So why wait? Enroll now and unlock exciting AI ML opportunities. The link is in the description box below.
In today's session, we will go through what is movie recommendation system.
After that, we will see how movie recommendation system work. Moving forward, we will see filtering strategies for movie recommendation system, and at the end, we will see hands-on lab demo like how to create movie recommendation system using Python in detail. We already have dataset with us. We will perform different function and implement a movie recommendation system using Python. Before we move on to the programming part, let's discuss what is movie recommendation system actually is and proceed further for the same. So, renting CDs and DVDs, reading local TV listenings, watching film strip projectors or recordings. All of this is a thing of the past today. All of the world's biggest film collection have been digitized and moved to the online streaming services like Netflix, HBO or YouTube. These platforms can now help us with what is possibly the most difficult task of all, choosing a movie. They have been enhanced with AI powered capabilities. Well, that is no longer a concern for you. It is finally time for machine learning to put its skills on display in the modern cinematic landscape. To create advanced predictive system for true movie expert, data scientists are prepared to investigate our behavioral patterns and those of movies. A movie recommendation system, also known as a movie recommender system, uses machine learning to predict or filter user film preferences based on their prior decision and actions. It is an advanced filtration system that anticipates the consumer in question potential, like selection for a domain specific item, a movie. So, after seeing what is movie recommendation system, let's move forward and see how movie recommendation system actually works. A movie recommendation system fundamental idea is a pretty straightforward. Every recommender system primarily consists of two components, users and items. User receive more prediction from the system and the actual movies are the products. Filtering and predicting only the movies that a matching user is most likely to wish to see in the main objective of movie recommendation system. The user information from the system database is used by the ML algorithm for these recommendation system. Based on information from the past, this data is used to forecast the user in question's behavior in the future. Data should be handled by experts because it is so crucial to ML projects, including the movie recommendation system. After seeing how movie recommendation system works, let's see some filtration strategies for movie recommendation system. To assist user in finding the most relevant films, movie recommendation system employ a variety of filtration techniques and algorithms. The content-based filtering and the collaborative filtering system subcategories of the ML algorithm used for the movie recommendations are the most well-liked ones. Filtering based on content or content-based filtering, a method of filtering movies in a movie recommendation system that makes advantage of the item's data. This information, which is taken from the just one user, is quite important in this case. This technique uses an ML algorithm to suggest movies that are comparable to the user's past choices. Therefore, the information about the prior movie choices and likes just one person is used to generate similarity in content-based filtering. And the second one is collaborative filtering. As the name implies, this filtering technique is based on the interaction between the relevant person and the other user. For the best outcomes, the system contrasts and compares these behaviors. It combines the film choices and uses patterns of several people. Like there are two types of collaborative filtering algorithm. The first one is collaborative filtering based on users. The goal is to find patterns in target users and other database users, like movie preferences. And the second one is collaborative item based filtering. The fundamental idea behind this is to find comparable products like movies, that target users rate or interact with. So after seeing the filtering strategies for movie recommendation system, so here is one question for you guys. I will give you 1 minute for this. You can comment or you can give answer in chat section, so I can see if the answers given by you are right or wrong. I'm repeating again. So here is one question for you guys. I will give you 1 minute, exactly 1 minute for this. You can comment or you can give your answer in chat section, so I can see if the answers given by you are right or wrong. So the question is, Which is the best language for machine learning programming? Which is the best language for machine learning? The first one is Java. The second one is Python. The third one is R language. And the fourth one is C++. So this is the question I am repeating again. Which is the best language for machine learning? The option one is Java, second Python, R language and C++. So I am starting timer of 1 minute. Just type your answers in comment section or in a chat section. Do let me know your answers. Please, I want that everyone should participate in this and make this live session interesting. So I am starting timer. Oh, your time starts now. Please guys, do let me know your answers in chat section or in you can comment down. $42 to go. You can comment or you can give your answer in the chat section so I can see if the answers given by you are right or wrong. 30 seconds more. Which is the best language for machine learning? You can give your answer in chat section or you can comment so I can see if the answers given by you are right or wrong. Guys, come on, please. I want that everyone should participate in this and make this live section interesting. Come on, guys, 5 seconds more. 1. Yup, time up. So, time is over. We will give reply those who gave correct answer and those who didn't give correct answer, we will give you a reply with the correct answer. So, now let's move to our programming part to perform movie recommendation system using Python. So, first we will open command prompt to write command to open Jupyter notebook. So, we will write Jupyter notebook, press enter. So this is the landing page of Jupyter notebook and select here new Python file. So this is how Jupyter notebook UI look like. So at first we will import some major libraries of Python which will help us in mathematical functioning. So the first one is NumPy. Import NumPy as NP. So NumPy is a Python library used for working with arrays. It also has a function for working in the domain of linear algebra and matrices. It is an open source project and you can use it freely. NumPy stands for numerical Python. So here NP is denoting NumPy. So we will import the next library. Import pandas as PD. This should be space. Yup. So pandas is a software library written for the Python programming language for data manipulation and analysis. In particular, it offers data structures and operation for manipulating numerical tables and time series. So after importing libraries, we will move ahead and import dataset. So for importing dataset, we have to write like we have two dataset with us. Let me show you the dataset. We have two dataset with us. The first one is credits. This one. And the second one is movies one. Movies one. So don't worry, you can get these dataset link in the description box. So let me write here credits underscore data frame equals to pd dot read underscore csv. Here you have to give your location of the dataset. credits dot csv. The second one is movies. Let's go data frame. This is for movie data frame. pd dot read csv. So here you have to give the movie location, movie dataset location, movies dot csv. Okay, everything seems good. Let me run this. Yeah. So then here PD is for the pandas library, read is used for reading the dataset from the machine, and CSV is used for the type of file which you want to read. So after this, let's write code to see the dataset. So we will write here credits underscore df, and we will run it. So this is our credit dataset, and next one is movies underscore. So this is our movie dataset. So this is how our board dataset look like. So here you can see 3 dots, this one, and here also this one. So we are unable to see our full dataset. Like what if we want like full 4803 rows? So at that case we can write here pd dot set underscore option. Okay, and here we will write display dot max underscore columns, this, and here we will write none. Same for the rows, pd dot set option display dot max underscore rows, none. Okay, none. Let's run this. So now if we will write credits underscore df, it is running. Yeah. So now you can see your full data set, like full credit data set with 4803 rows or 4802 rows, because this is starting from 0, that's why. So what about movies data set? Okay, wait, running. It is still running, you can see here. So here you can see the full data set, movie data set with 4802 rows. Or if you want to see only 5 top rows, so you can write here credits underscore df dot head. So by this only 5 top rows. So from head we can see our 5 top rows, and if we will use tail instead of head, we can see our last 5 rows. So here let me do with the movies one, df dot tail. Yeah. So here you can see 4798 row, 4799 till 4802. So with tail we can see our last 5 rows. So moving forward, let's merge the credit dataset to movie dataset, because if we will combine them, the confusion will be less, and at the end it will be better for us. So we will write here movies underscore equals to movies underscore data frame and credits underscore df on title. Okay, T is small, I guess. Yeah, perfect. Title. Let me do something like this. Okay, it is saying data frame object is not callable. Credits underscore df movies. Okay, why? Because we haven't wrote merge here. Now it will work. Yeah, perfect. It's working. So data is merged. Let's see the number of rows and column using shape function. So now we have only one. So movies underscore df dot shape. Okay, let's run it. 4809 and 23. But if we see here, like in movies dataset, so in movies dataset, here, yeah, there are 20, and in here we are 4 columns in credit dataset. So like, so you will be thinking, that's why not 24, why only 23 columns? That is why on title, you can see here on title, the titles in both titles are same. You can see here both titles are same in both. Okay, let me show you like this. Okay, Avatar, Pirates of the Caribbean, Spectre, and so on. Here you can see Avatar, Pirates of the Caribbean, Spectre, and so on. So that is why on title, written while merging, so title are same. So moving forward, let's see our merged dataset. So we will write only movies underscore data frame dot head. Yeah. So our data is merged. You can see the last cast, crew, movie ID. Yeah, you can see here movie ID, title are the same. They are merged, cast, crew. Okay, guys. Let me give some more for the better view. Yeah. So you can see all columns of credit dataset are added to movies one. So moving forward, let's see another function like movies underscore df dot info. So by this, yes, you can see. So by this, the data frame information is printed via the info method. The data includes the total number of columns, their labels, data kinds, memory use, range index, and the number of cells in each column, like non-null values. Note that info method does indeed print the information. So here you can see all the information is printed. Okay, like columns name and the all null values, count, and data types too, like this int, object, int, in which we are working most. So after this, let's move forward and select some main column in which we are working most. So we will write movies underscore df equals to movies underscore df underscore d title, comma, and the another one is overview. Okay, why? Okay, here we have to get like this. Yeah. So here we have to write genre. Genre is complete, and we will work on what keywords. Keywords are the main keywords. Okay, keywords. Then to cast. Then we will do recommendation with the crew as well. Okay. So by running this, let me see our data again with 7. Okay, there is one error. Okay, this is movie. The movie ID or genre, no? Yeah. not in index. Okay, got it, got it. Why not genre? It's genres, I guess. What it is, it's genres. That's why. It's genres. Okay. Yeah, so let's see our data again with 7 columns. So I will write here movies underscore df dot head here. Right. So you can see only we have like movies ID, same title, overview, genres, keywords, cast and crew only. So here you can see the selected columns. Okay, so let's move forward, and once again let's see the info again, like movies underscore df dot info is come with selected columns, and let's move forward and see how many missing values are present in particular column. So like the columns is full, we can see here, but we don't know about that 4803 values are filled or not. So what we will do it, we will see how many missing values are present there. So here we will write like movies underscore df dot is null dot sum. Not like this. Yeah, perfect. So the function data frame is null, this one is null dot sum. Dot sum returns the number of missing values in the dataset. So here you can see overview have 3 missing values. So what we can do is we can write here movies underscore df dot drop na place equals to true. Okay, we will run it. It's saying okay, it's document drop na equals to true. Okay, fine. Dot underscore drop na, and yeah, it will not create an issue. So if you set in place equals to true, the drop na method will modify your data frame directly. That means that if you set in place equals to true, the drop na will drop all missing values from your original data set. Let's move forward and see movies underscore df dot duplicated So the duplicate method returns a series with true and false values that describe which rows in the data frame are duplicated or not. Use the subset parameter to specify if any column should not be considered when looking for duplicates. So here let me run this first. So here we are getting 0. Why 0? So if you are like thinking there is no true or false return, so if you write it without sum, like if I will write it without sum, okay, let me copy from here, yeah, and I will run this. So here you can see false, false, false in whole data set. So sum will combine them and return you a value. At the end 0 represent false itself. So we do not need this, so we will write something else. So moving forward, let me write first movies underscore df dot iLocation 0 dot genres. Let me run this. So the ilog function, this one, ilog function. First let me do something like this. It will go up. Okay, okay, so from ilog function in Python is defined in the pandas module that helps us to select a specific row or column from the dataset. Using the ilog method in Python, we can easily retrieve any particular value from a row or column by using index value. So here 0th position line is coming, which is here you can see. So name action, like name action, name adventure, name fantasy, this sci fiction, this one science fiction. Yeah. So this is because I am giving here genre. That is why you can see here. See ID 28 name action, name something 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 like that. Okay. So let's import something called AST, abstract syntax tree. So this is one of the major library. Import AST. Let me run this. Import is a class defined is the AST module that is used to express the import statement in Python in the form of abstract syntax tree. So an abstract syntax tree or just syntax tree is a tree representation of the abstract syntactic structure of text written in a formal language. Each node of the tree denotes a construct occurring in the text. So let's convert some like literal to object and append them. So here I will write def convert obj object like L equals to blank array for I in ast dot literal repeat ev bj object. Okay, like L dot append return here we are converting is like here is a convert is a function and L is a array to append by using for loop. We can append them to name. So let me write code, then I will explain like what is happening. So let me write full code. So movies underscore df like genres, okay, equals to movies genres and then dot apply what so then movies underscore df, then I will write keywords equals to movies underscore df keywords apply underscore df dot so if we will see our old data set in that like we will see old data set in that genre and that's keyword this keyword apps id name and so on like id that name like this type of things. So it will create a mess in retrieving them. So by using AST library we just convert them to the normal one like title. So got it guys. So I hope you guys understand till here. If you have any question or any query regarding any code or question, just put as in comment. Our team will shortly provide you the correct solution. I'm repeating again. I hope you guys understand till here. If you have any type of questions regarding any code or something, so just put as in comments. Our team will shortly provide you the correct solution. So moving forward, let's convert cast to and like same as previous way, like this only. So what we will do here, we will write def convert
Yeah, here I am using. So L equals to counter equals to 0. St dot literal if counter does not equals to 3, then L dot L dot append. Okay, then here I have to write I to name. Okay, counter equals to 1. If you want to write like counter is equals to counter plus 1, it is like both the same. Else take done L. So let me run this. Okay, so after this small code, we have to assign the values. Like we are doing it for cast now. So movies. Okay, movies underscore df, then cast equals to movies underscore df cast dot apply convert. Everything seems good. So let's see the changes are visible or not. So we will write here movies underscore df dot head. You can ignore this, like this is nothing. So here you can see cast is also same like keyword and genre. So like let's do for the crew too. So like we are converting, you can say, in a structured way. So let's do for the crew one too. So let me put some, yeah. So here we will add def like fetch, which is nothing like a function name, fetch director obj. Okay, colon L equals to for I in ast dot literal obj if I job also is equals to, like we can say, director. So then L dot append mm, L dot append to the same name, but return okay, capital L. So we have to again write that movies crew equals to movies in crew apply h. Just remember, fetch director is a function name. Let's see changes. So here I have to write movies, then press enter. So yeah, crew is all set. So changes are visible and data is looking good. So what we like, if I want to see the first movie avatar overview, this like this dot 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 dot, so I have to write here like movies overview at 0th place. So yeah, so this is a full overview of Avatar movie. Like, let me read for this. In this 22nd century, a paraplegic marine is dispatched and blah 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 and civilization. So moving forward, that what we want to recommend movie in the basis of overview, genre, keyword, cast. So for that we need a separate words, like in the then 22nd century along. So if you will see in other columns, all the words are separated, but like here, if you will see, all the words are separated. Like action is separated, adventure is separated, fantasy is separated. So there is a long sentence in this one, in the overview one. There's a long sentence. So it's difficult to recommend from this. So what we are going to do is, well, we will separate them like other columns. So here we will write movies overview equals to movies then overview and dot apply my bad, sorry, then lambda colon x dot split, yeah, error. So let's see the results. So movies, yeah, you can see in the set one. So now you can see all the words are separated by comma. So now it will easy to match overview to recommend a particular movie. So moving forward, so what we are going to do is, if there is a two word and space between there, so we are going to remove that space. So here you can see science fiction are separate. Okay, so we are going to remove this one, this space. So let's write code for that. So here I will write like overview is already done, so we will not do for that. So let's write code for the rest columns. So here I have to write movies like genres equals to movies, and again genres dot apply lambda x I dot replace space to no space. It seems good. Then I have to write for everywhere. So for I in x, it's for I in x, movies genres equals to movie genres dot apply lambda x I dot replace this to this for, seems good. So let's copy paste this. See, one for keywords and one for cast and crew. Cast first, then you rest is same. So let me run this. Okay, no error, seems good. So let's see the changes. So movies. Yeah. So now you can see the science fiction space is gone. Like here is science fiction space is there. Now science fiction space is gone. Yep. So like okay, let's move forward and create one new column name as tag and put all the column data in a particular column. Okay, let me do first. Yeah, let me write movies. This is a column or one column name equals to movies. Then first we will put overview plus movies and genres and movies. And what we have to give keywords, then again movies, then cast, me run this. Okay, so let's see the data frame. Movies. Okay, still coming. So like there is one problem, I guess. Yeah, no. So here you can see all the data is merged in a under tag column. Yes, you can see like in the second century, blah blah blah. So I hope you guys understand till here. If you have any question or any query regarding any code or anything, just put as in comment or our team will shortly provide you the correct solution. Okay, so I'm repeating again. I hope you guys understand till here. If you have any question or any query regarding any code or like any question, just put as in comment. Our team will shortly provide you the correct solution. So from here, let's create a new data frame. Okay. So let me create new data frame because now we don't need this overview, cast, crew, genre, like columns like this. We have already merged into a one column like tag column. So we will write here new df equals to movies. Okay. So like movies, we need movie ID. New data frame, we need movie ID, comma, we need title, and we have everything in tags column. So we need tags column. Okay, let's run this. Let's see our new data frame. Yeah. So this is how our new data look like with only 3 columns like movie ID, title, and tags. So here you can see array brackets like this array brackets. So we are gonna remove them. So we will do what we will write here. We will write new data frame that in tags equals to new data frame tags dot apply lambda x, then I will give space dot join seems good, everything is okay. Okay, fine. Yeah, so let's see the results. So we will write here new underscore data frame. So you can see the brackets are removed. Now let's see the data which is present in the 0th index in tag column like this dot 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 in the okay, for that we have to write here a new data frame tags. We did it before like for the overview. So here we have to, yeah. So this is the whole data in the first index, 0th index. So some part of the overview like from civilization, and some are, you can see this action, adventure, fantasy, science fiction. These are some like genres, and like here you can see like these are some crews members, and yeah, like Sam Worthington, like there are some cast crew. Okay, so like moving forward, like what we are going to do is just make them in lowercase for the better prediction, like something in capital and something like smaller. So let's make it to lowercase. So new underscore df tax equals to new underscore df tax dot apply yeah colon x dot lower. Okay, so don't worry about this error. Let's see the result. New underscore df dot yeah, now all the data present at tag column is in small case, or you can say lowercase. Moving forward, let's do some feature extraction using count vectorizer. So let me write first from sklearn dot feature extraction. Okay, cool. Dot text import count vectorizer cv equals to count vectorizer underscore features equals to like 5000 top words equals to English. And this, yeah. So count vectorizer. Okay, there is a, I cannot import count vectorizer from sklearn from user. Okay, sorry, my bad. Here V is capital. Okay, guys, so V is capital. Yeah, so no error. So count vectorizer is a great tool provided by the scikit-learn library in Python. It is used to transform a given text into a vector on the basis of the frequency count of each word that occurs in the entire text. So let me write something. Cv dot fit underscore transform f x like dot to array shape. Okay, so the fit method like learns a vocabulary dictionary of all tokens in the raw documents. That is, it creates a dictionary of tokens. By default, the tokens are words separated by spaces and like punctuation. So that maps each single token to a position in the output matrix. So here CV is a counter vectorizer. So let's convert into vector to array. So for this we have to write vectors equals to cv dot fit, okay, then transform x in So here we have to write dot to array. Yeah, then we have to write vector its vectors. Yeah, you can see vector to array all the zeros. Okay, so moving forward, let's get the feature name by writing. Okay, so we will write here len cv dot get feature names feature names. Okay, then bracket yeah. So okay, we have like 500 feature names. So I'm saying again, like I hope you guys understand till here. If you have any question or any query regarding any code, whatever it is, so just put as in comments. Our team will shortly provide you the correct solution. Okay guys, like any code or you are not understand anything, just put as in comment. Our team will shortly provide you the correct solution. So let's import some major library, which is import NLTK. So what is NLTK? The Natural Language Toolkit NLTK is a platform used for building Python programs that work with human language for applying in statistical natural language processing NLP. It contains text processing libraries for tokenization, parsing, classification, stemming, tagging, and semantic reasoning. So moving forward, like from, let me write first, from n NLTK dot stem dot porter import porter ps equals to porter stemming is a process for reducing a word to its word stem, that suffix and prefix or to the roots of words known as a lemma. Stemming is important in natural language understanding NLU and natural language processing NLP. So here, like I have to write, so here I will write def stem to text y equals to for I in text dot split y dot append dot stem done. Dot join y. So let's apply stemming to a tag column. So here we will write new df tags equals to new df tag dot apply stem. So let's import cosine similarity from sklearn. So here we will write from sklearn dot matrices dot pairwise import cosine underscore similarity. Okay, it seemed good from sklearn matrices matrix dot pairwise, it is pairwise import cosine similarity. Okay, let's run this. No error. So cosine similarity measures the similarity between two factors. I repeat, cosine similarity measures the similarity between two vectors of an inner product space. It is measured by the cosine of the angle between two vectors and determines whether two vectors are pointing in roughly the same direction. It is often used to measure document similarity in text analysis. So here we will write cosine underscore similarity vectors. So these all are the vector present. Let's see the cosine similarity vector column and row using space. So here I will write cosine similarity vectors dot shape. So it's still running, you can see here. Yeah. So 4806 rows and 4806 columns are there. Let's assign variable similarity to this. Okay. So let's similarity, we'll write like this. Similarity equals to cosine similarity underscore here. Why I did this? Because we don't have to write always this long sentence or long keyword, you can say. So moving forward, let's see first column. Like we will write similarity yeah. So this is our first column. So let's see the rows only. So we will write here similarity 0 dot shape. Okay, 4806. Okay. So let's move forward and let's create some like sorted list. So for that, sorted. Okay. List enumerate spelling is fine. Okay, one more like similarity 0 here I have to write reverse equals to true comma key equals to lambda colon x, not capital X, x. I have to write 1 colon 6. Seems good. Yeah. So the enumerate function in Python converts a data collection object into an enumerate object. Enumerate returns an object that contains a counter as a key for each value with an object, making item within a collection easier to access. So finally, let's create the recommend function to check the movie recommendation system. Okay. So let's write here def recommend movie x. So new df in the df title equals to movie x 0 distances equals to similarity and movie. Okay, so movies list equals to sorted list enumerate RAT enumerate distances comma reverse equals to true keyword sorry key only key equals to lambda x colon x 1 and colon 6 or I in movies list df dot iloc I 0 0 dot title because we need title only. So yeah, it seems good. Okay, so finally that time is came. So finally the time is come to check the recommendation of your favorite movies. So you can comment in the chat section so I can check. So let me write first recommend for movie Avatar. Okay, so here you can see the recommendation system is working fine. So Titan A.E, Small Soldier, Independence Day are the recommendation for the movie Avatar. So let me check for the another one recommend for one of my favorite movie Iron Man. So here you can see Iron Man 2, Iron Man 3, Avengers Age of Ultron, Captain America and the Avengers are the recommendations for the movie Iron Man. So let me check for the one more recommend Liar. It is going on 30 and the last one I want to check is Captain America Civil War. Let me copy from here only. Yeah, you can see the Captain America, the first Avenger, the Winter Soldier, Iron Man 3, Age of Ultron, the Avengers. So I hope you guys understand till here. If you have any questions or any query regarding any code or question, just put as in comments. Our team will shortly provide you the correct solution.
If you are an aspiring AI ML engineer, then there is no better time to train yourself in the exciting field of AI. If you are looking for a course that covers everything from fundamental to advanced techniques, then accelerate your career in AI and ML with our comprehensive postgraduate program in AI and machine learning. So why wait? Enroll now and unlock exciting AI ML opportunities. The link is in the description box below.
Hello everyone, welcome to this session. I'm Mohan from Simplilearn and today we'll talk about interview questions for machine learning. Now, this video will probably help you when you're attending interviews for machine learning positions, and the attempt here is to probably consolidate 30 most commonly asked questions and to help you in answering these questions. We tried our best to give you the best possible answers, but of course what is more important here is rather than the theoretical knowledge, you need to kind of add to the answers or supplement your answers with your own experience. So the responses that we put here are a bit more generic in nature, so that if there are some concepts that you are not clear, this video will help you in kind of getting those concepts cleared up as well. But what is more important is that you need to supplement these responses with your own practical experience. Okay, so with that, let's get started. So one of the first questions that you may face is, what are the different types of machine learning? Now, what is the best way to respond to this? There are three types of machine learning. If you read any material, you will always be told there are three types of machine learning. But what is important is you would probably be better off emphasizing that there are actually two main types of machine learning, which is supervised and unsupervised. And then there is a third type, which is reinforcement learning. So supervised learning is where you have some historical data and then you feed that data to your model to learn. Now, you need to be aware of a keyword that they will be looking for, which is labeled data. Right? So if you just say past data or historical data, the impact may not be so much. You need to emphasize on labeled data. So what is labeled data? Basically, let's say if you're trying to train your model for classification, you need to be aware of, for your existing data, which class each of the observations belong to, right? So that is what is labeling. So it is nothing but a fancy name, you must be already aware, but just make it a point to throw in that keyword labeled, so that will have the right impact. Okay, so that is what is supervised learning, when you have existing labeled data which you then use to train your model. That is known as supervised learning. And unsupervised learning is when you don't have this labeled data. So you have data, it is not labeled. So the system has to figure out a way to do some analysis on this. Okay, so that is unsupervised learning. And you can then add a few things like what are the ways of performing supervised learning and unsupervised learning, or what are some of the techniques. So supervised learning, we perform, or we do regression and classification, and unsupervised learning we do clustering. Okay? And clustering can be of different types. Similarly, regression can be of different types, but you don't have to probably elaborate so much. If they are asking for just the different types, you can just mention these and just at a very high level you can. But if they want you to elaborate, give examples, then of course I think there is a different question for that. We will see that later. Then the third, so we have supervised, then we have unsupervised, and then reinforcement. You need to provide a little bit of information around that as well, because it is sometimes a little difficult to come up with a good definition for reinforcement learning. So you may have to a little bit elaborate on how reinforcement learning works. Right? So reinforcement learning works in such a way that it basically has two parts to it. One is the agent and the environment. And the agent basically is working inside of this environment, and it is given a target that it has to achieve. And every time it is moving in the direction of the target, so the agent basically has to take some action. And every time it takes an action which is moving the agent towards the target, right, towards a goal. A target is nothing but a goal. Okay, then it is rewarded, and every time it is going in a direction where it is away from the goal, then it is punished. So that is the way you can a little bit explain. And this is used primarily, or very, very impactful for teaching the system to learn games and so on. Examples of this are basically used in AlphaGo. You can throw that as an example where AlphaGo used reinforcement learning to actually learn to play the game of Go, and finally it defeated the Go world champion. All right, this much of information that would be good enough. Okay. Then there could be a question on overfitting. So the question could be, what is overfitting and how can you avoid it? So what is overfitting? So let's first try to understand the concept, because sometimes overfitting may be a little difficult to understand. Overfitting is a situation where the model has kind of memorized the data. So this is an equivalent of memorizing the data. So we can draw an analogy so that it becomes easy to explain this. Now let's say you're teaching a child about recognizing some fruits or something like that. Okay, and you're teaching this child about recognizing, let's say, 3 fruits: apples, oranges, and pineapples. Okay, so this is a small child, and for the first time you're teaching the child to recognize fruits. Then, so what will happen? So this is very much like that is your training data set. So what you will do is you will take a basket of fruits which consists of apples, oranges, and pineapples. Okay, and you take this basket to this child, and there may be, let's say, hundreds of these fruits. So you take this basket to this child and keep showing each of this fruit, and then first time obviously the child will not know what it is. So you show an apple and you say, hey, this is apple. Then you show maybe an orange and say this is orange, and so on and so forth. And then again you keep repeating that, right? So till that basket is over. This is basically how training works in machine learning. Also, that's how training works. So till the basket is completed, maybe 100 fruits, you keep showing this child. And in the process, what has happened, the child has pretty much memorized these. So even before you finish that basket, right, by the time you are halfway through, the child has learnt about recognizing the apple, orange, and pineapple. Now what will happen after halfway through? Initially you remember it made mistakes in recognizing, but halfway through now it has learned. So every time you show a fruit, it will exactly 100% accurately, it will identify. It will say, the child will say this is an apple, this is an orange, and if you show a pineapple, it will say this is a pineapple. Right? So that means it has kind of memorized this data. Now let's say you bring another basket of fruits, and it will have a mix of maybe apples, which were already there in the previous set, but it will also have, in addition to apple, it will probably have a banana or maybe another fruit like a jackfruit. Right? So this is an equivalent of your test data set, which the child has not seen before. Some parts of it probably has seen, like the apples it has seen, but this banana and jackfruit it has not seen. So then what will happen? In the first round, which is an equivalent of your training data set, towards the end, it has 100% it was telling you what the fruits are. Right? Apple was accurately recognized, orange was accurately recognized, and pineapples were accurately recognized. Right? So that is like 100% accuracy. But now when you get a fresh set which were not a part of the original one, what will happen? All the apples maybe it will be able to recognize correctly, but all the others like the jackfruit or the banana will not be recognized by the child. Right? So this is an analogy, this is an equivalent of overfitting. So what has happened during the training process, it is able to recognize or reach 100% accuracy, maybe very high accuracy. Okay, and we call that as very low loss. Right? So that is the technical term. So the loss is pretty much 0 and accuracy is pretty much 100%. Whereas when you use testing, there will be a huge error, which means the loss will be pretty high and therefore the accuracy will be also low. Okay, this is known as overfitting. This is basically a process where training is done. Training process it goes very well, almost reaching 100% accuracy, but while testing, it really drops down. Now, how can you avoid it? So that is the extension of this question. There are multiple ways of avoiding overfitting. There are techniques like what you call regularization. That is the most common technique that is used for avoiding overfitting. And within regularization, there can be a few other subtypes like dropout in case of neural networks and a few other examples. But I think if you give example or if you give regularization as the technique, probably that should be sufficient. So there will be some questions where the interviewer will try to test your fundamentals and your knowledge and depth of knowledge and so on and so forth. And then there will be some questions which are more like trick questions that will be more to stump you. Okay, then the next question is around the methodology. So when we are performing machine learning training, we split the data into training and test, right? So this question is around that. So the question is, what is training set and test set in machine learning model, and how is the split done? So the question can be like that. So in machine learning, when we are trying to train the model, so we have a 3-step process. We train the model and then we test the model, and then once we are satisfied with the test, only then we deploy the model. So what happens in the train and test is that you remember the labeled data. So let's say you have 1,000 records with labeling information. Now, one way of doing it is you use all the 1,000 records for training, and then maybe right? Which means that you have exposed all these 1,000 records during the training process, and then you take a small set of the same data and then you say, okay, I will test it with this. Okay, and then you probably, what will happen, you may get some good results. Right? But there is a flaw there. What is the flaw? This is very similar to human beings. It is like you are showing this model the entire data as a part of training. Okay, so obviously it has become familiar with the entire data. So when you're taking a part of that again and you're saying that I want to test it, obviously you will get good results. So that is not a very accurate way of testing. So that is the reason what we do is we have the labeled data of this 1,000 records or whatever. We set aside, before starting the training process, we set aside a portion of that data and we call that test set, and the remaining we call as training set, and we use only this for training our model. Now, the training process, remember, is not just about passing one round of this data set. So let's say now your training set has 800 records. It is not just one time you pass this 800 records. What you normally do is you actually, as a part of the training, you may pass this data through the model multiple times. So this 1,000 records may go through the model maybe 10, 15, 20 times till the training is perfect, till the accuracy is high, till the errors are minimized. Okay, now, so which is fine, which means that that is what is known as the model has seen your data and gets familiar with your data. And now when you bring your test data, what will happen is this is like some new data, because that is where the real test is. Now you have trained the model and now you are testing the model with some data which is kind of new. That is like a situation, like a realistic situation, because when the model is deployed, that is what will happen. It will receive some new data, not the data that it has already seen, right? So this is a realistic test. So you put some new data. So this data which you have set aside is for the model, it is new. And if it is able to accurately predict the values, that means your training has worked. Okay, the model got trained properly. But let's say while you're testing this with this test data, you're getting a lot of errors. That means you need to probably either change your model or retrain with more data and things like that. Now, coming back to the question of how do you split this, what should be the ratio? There is no fixed number. Again, this is like individual preferences. Some people split it into 50-50, 50% test and 50% training. Some people prefer to have a larger amount for training and a smaller amount for test. So they can go by either 60-40 or 70-30, or some people even go with some odd numbers like 65-35 or 63.33 and 33, which is like 1/3 and 2/3. So there is no fixed rule that it has to be something, the ratio has to be this. You can go by your individual preferences. Alright, then you may have questions around data handling, data manipulation, or what do you call data management or preparation. So these are all some questions around that area. There is again no one answer, one single good answer to this. It really varies from situation to situation, and depending on what exactly is the problem, what kind of data it is, how critical it is, what kind of data is missing, and what is the type of corruption. So there are a whole lot of things. This is a very generic question, and therefore you need to be a little careful about responding to this as well. So probably have to illustrate this again. If you have experience in doing this kind of work in handling data, you can illustrate with examples saying that I was on one project where I received this kind of data. These were the columns where data was not filled, or these were this many rows where the data was missing. That would be, in fact, a perfect way to respond to this question. But if you don't have that, obviously, you have to provide some good answer. I think it really depends on what exactly the situation is. And there are multiple ways of handling the missing data or corrupt data. Now, let's take a few examples. Now, let's say you have data where some values in some of the columns are missing, and you have pretty much half of your data having these missing values in terms of number of rows. Okay, that could be one situation. Another situation could be that you have records or data missing, but when you do some initial calculation, how many records are corrupt, or how many rows or observations, as we call it, has this missing data. Let's assume it is very minimal, like 10%. Okay. Now, between these two cases, how do we? So let's assume that this is not a mission critical situation, and in order to fix this 10% of the data, the effort that is required is much higher, and obviously effort means also time and money, right? So it is not so mission critical, and it is okay to, let's say, get rid of these records. So obviously one of the easiest ways of handling the data part or missing data is remove those records or remove those observations from your analysis. So that is the easiest way to do. But then the downside is, as I said as in the first case, if let's say 50% of your data is like that, because some column or the other is missing. So it is not like in every place, in every row, the same column is missing, but you have in maybe 10% of the records, column 1 is missing, and another 10% column 2 is missing, another 10% column 3 is missing, and so on and so forth. So it adds up to maybe half of your data set. So you cannot completely remove half of your data set, then the whole purpose is lost. Okay, so then how do you handle? Then you need to come up with ways of filling up this data with some meaningful value, right? That is one way of handling. So when we say meaningful value, what is that meaningful value? Let's say for a particular column, you might want to take a mean value for that column and fill wherever the data is missing, fill up with that mean value, so that when you're doing the calculations, your analysis is not completely way off. So you have values are not missing, first of all, so your system will work. Number two, these values are not so completely out of whack that your whole analysis goes for a toss. Right? There may be situations where if the missing values, instead of putting mean, maybe a good idea to fill it up with the minimum value or with a 0. So, or with a maximum value. Again, as I said, there are so many possibilities. So there is no like one correct answer for this. You need to basically talk around this and illustrate with your experience. As I said, that would be the best. Otherwise, this is how you need to handle this question. Okay, so then the next question can be, how can you choose a classifier based on a training set data size? So again, this is one of those questions where you probably do not have like a one size fits all answer. First of all, you may not, let's say, decide your classifier based on the training set size. Maybe not the best way to decide the type of the classifier. And even if you have to, there are probably some thumb rules which we can use. But then again, every time, so in my opinion, the best way to respond to this question is you need to try out few classifiers irrespective of the size of the data, and you need to then decide on your particular situation which of these classifiers are the right ones. This is a very generic issue, so you will never be able to just by, if somebody defines a problem to you and somebody, even if they show the data to you or tell you what is the data or even the size of the data, I don't think there is a way to really say that yes, this is the classifier that will work here. No, that's not the right way. So you need to still, test it out, get the data, try out a couple of classifiers, and then only you will be in a position to decide which classifier to use. You try out multiple classifiers, see which one gives the best accuracy, and only then you can decide. Then you can have a question around confusion matrix. So the question can be, explain confusion matrix. Right? So confusion matrix, I think the best way to explain it is by taking an example and drawing like a small diagram. Otherwise it can really become tricky. So my suggestion is to take a piece of pen and paper and explain it by drawing a small matrix. And confusion matrix is about to find out, this is used especially in classification learning process, and when you get the results, when our model predicts the results, you compare it with the actual value and try to find out what is the accuracy. Okay, so in this case, let's say this is an example of a confusion matrix, and it is a binary matrix. So you have the actual values, which is the labeled data, right? And which is, so you have how many yes and how many no. So you have that information, and you have the predicted values, how many yes and how many no, right? So the total actual values, the total yes is 12 plus 1, 13, and they are shown here. And the actual value no's are 9 plus 3, 12. Okay, so that is what this information here is. So this is about the actual and this is about the predicted. Similarly, the predicted values, there are yes are 12 plus 3, 15 yeses, and no are 1 plus 9, 10 no's. Okay, so this is the way to look at this confusion matrix. Okay, and out of this, what is the meaning conveyed here? So there are 2 or 3 things that needs to be explained outright. The first thing is, for a model to be accurate, the values across the diagonal should be high, like in this case, right? That is one. Number 2, the total sum of these values is equal to the total observations in the test data set. So in this case, for example, you have 12 plus 3, 15 plus 10, 25. So that means we have 25 observations in our test data set. Okay, so these are the 2 things you need to first explain, that the total sum in this matrix, the numbers, is equal to the size of the test data set, and the diagonal values indicate the accuracy. So by looking at it, you can probably have an idea about, is this an accurate model? Is the model being accurate? If they're all spread out equally in all these 4 boxes, that means probably the accuracy is not very good. Okay. Now, how do you calculate the accuracy itself, right? How do you calculate the accuracy itself? So it is a very simple mathematical calculation. You take sum of the diagonals, right? So in this case, it is 9 plus 12, 21, and divide it by the total. So in this case, what will it be? Let me take a pen. So your diagonal values is equal to, if I say D is equal to 12 plus 9, so that is 21, right? And the total data set is equal to, right, we just calculated, it is 25. So what is your accuracy? It is 21 by, so your accuracy is equal to 21 by 25, and this turns out to be about 85%. Right? So this is 85%. So that is our accuracy. Okay. So this is the way you need to explain, draw a diagram, give an example, and maybe it may be a good idea to be prepared with an example so that it becomes easy for you. You don't have to calculate those numbers on the fly, right? So a couple of hints are that you take some numbers which add up to 100. That is always a good idea, so you don't have to really do this complex calculations. So the total value will be 100, and then diagonal values you divide. Once you find the diagonal values, that is equal to your percentage. Okay. All right. So the next question can be a related question about false positive and false negative. So what is false positive and what is false negative? Now, once again, the best way to explain this is using a piece of paper and pen. Otherwise, it will be pretty difficult to explain this. So we use the same example of the confusion matrix, and we can explain that. So a confusion matrix looks somewhat like this, and when we just take it looks somewhat like this, and we continue with the previous example where this is the actual value, this is the predicted value, and in the actual value we have 12 plus 1 13 yeses and 3 plus 9 12 no's, and the predicted values, there are 12 plus 3 15 yeses and 1 plus 9 10 no's. Okay. Now, in this particular case, which is the false positive, what is a false positive? First of all, the second word, which is positive, okay, is referring to the predicted value. So that means the system has predicted it as a positive, but the real value, so this is what the false comes from, but the real value is not positive. Okay, that is the way you should understand this term, false positive or even false negative. So false positive, so positive is what your system has predicted. So where is that system predicted? This is the one. Positive is what? Yes. So you basically consider this row. Okay. Now if you consider this row, so this is all positive values. This entire row is positive values. Okay. Now the false positive is the one where the actual value is negative. Predicted value is positive, but the actual value is negative. So this is a false positive, right? And here is a true positive. So the predicted value is positive and the actual value is also positive. Okay, I hope this is making sense. Now let's take a look at what is false negative. False negative. So negative is the second term. That means that is the predicted value that we need to look for. So which are the predicted negative values? This row corresponds to predicted negative values. All right. So this row corresponds to predicted negative values. And what they are asking for? False. So this is the row for predicted negative values, and the actual value is this one, right? This is predicted negative and the actual value is also negative. Therefore, this is a true negative. So the false negative is this one. Predicted is negative, but actual is positive. right? So this is the false negative. So this is the way to explain, and this is the way to look at false positive and false negative. Same way, there can be true positive and true negative as well. So again, positive, the second term you will need to use to identify the predicted row, right? So if we say true positive, positive we need to take for the predicted part. So predicted positive is here. Okay, and then the first term is for the actual. So true positive. So true in case of actual is yes, right? So true positive is this one. Okay, and then in case of actual, the negative. Now we are talking about, let's say, true negative. True negative. Negative is this one, and the true comes from here. So this is true negative, right? 9 is true negative. The actual value is also negative, and the predicted value is also negative. Okay, so that is the way you need to explain this, the terms false positive, false negative, and true positive, true negative. Then you might have a question like, what are the steps involved in the machine learning process, or what are the 3 steps in the process of developing a machine learning model, right? So it is around the methodology that is applied. So basically, the way you can probably answer in your own words, but the way the model development of the machine learning model happens is like this. So first of all, you try to understand the problem and try to figure out whether it is a classification problem or a regression problem. Based on that, you select a few algorithms, and then you start the process of training these models. Okay, so you can either do that, or you can, after due diligence, you can probably decide that there is one particular algorithm which is most suitable. Usually it happens through trial and error process, but at some point you will decide that, okay, this is the model we are going to use. Okay, so in that case, we have the model, algorithm, and the model decided, and then you need to do the process of training the model and testing the model. And this is where, if it is supervised learning, you split your data, the labeled data, into training data set and test data set. And you use the training data set to train your model. And then you use the test data set to check the accuracy, whether it is working fine or not. So you test the model before you actually put it into production, right? So once you test the model, you're satisfied it's working fine, then you go to the next level, which is putting it for production. And then in production, obviously new data will come, and the inference happens. So the model is readily available, and only thing that happens is new data comes and the model predicts the values, whether it is regression or classification. Now, so this can be an iterative process. So it is not a straightforward process where you do the training, do the testing, and then you move it to production. No. So during the training and test process, there may be a situation where, because of either overfitting or things like that, the test doesn't go through, which means that you need to put that back into the training process. So that can be an iterative process. Not only that, even if the training and test goes through properly and you deploy the model in production, there can be a situation that the data that actually comes, the real data that comes, with that, this model is failing. So in which case you may have to once again go back to the drawing board. Or initially it will be working fine, but over a period of time, maybe due to the change in the nature of the data, once again the accuracy will deteriorate. So that is again a recursive process. So once in a while, you need to keep checking whether the model is working fine or not. And if required, you need to tweak it and modify it, and so on and so forth. So net, this is a continuous process of tweaking the model and testing it and making sure it is up to date. Then you might have question around deep learning. So because deep learning is now associated with AI, artificial intelligence, and so on. So it can be as simple as, what is deep learning? So I think the best way to respond to this could be, deep learning is a part of machine learning. And then obviously the question would be, then what is the difference, right? So deep learning, you need to mention there are 2 key parts that interviewer will be looking for when you are defining deep learning. So first is, of course, deep learning is a subset of machine learning. So machine learning is still the bigger, let's say, scope, and deep learning is one part of it. So then what exactly is the difference? Deep learning is primarily when we are implementing these our algorithms, or when we are using neural networks for doing our training and classification and regression and all that, right? So when we use neural network, then it is considered as deep learning. And the term deep comes from the fact that you can have several layers of neural networks, and these are called deep neural networks, and therefore the term deep learning. The other difference between machine learning and deep learning, which the interviewer may be wanting to hear, is that in case of machine learning, the feature engineering is done manually. What do we mean by feature engineering? Basically, when we are trying to train our model, we have our training data, right? So we have our training labeled data, and this data has several, let's say if it is a regular table, it has several columns. Now each of these columns actually has information about a feature, right? So if we are trying to predict height, weight, and so on and so forth, so these are all features of human beings. Let's say we have census data and we have all this. So those are the features. Now there may be probably 50 or 100, in some cases there may be 100 such features. Now all of them do not contribute to our model, right? So we as a data scientist, we have to decide whether we should take all of them, all the features, or we should throw away some of them, because again, if we take all of them, number one, of course your accuracy will probably get affected, but also there is a computational part. So if you have so many features and then you have so much data, it becomes very tricky. So in case of machine learning, we manually take care of identifying the features that do not contribute to the learning process, and thereby we eliminate those features and so on. Right? So this is known as feature engineering, and in machine learning we do that manually. Whereas in deep learning, where we use neural networks, the model will automatically determine which features to use and which to not use, and therefore feature engineering is also done automatically. So this is an explanation. These are two key things probably will add value to your response. All right, so the next question is, what is the difference between, or what are the differences between machine learning and deep learning? So here, this is a quick comparison table between machine learning and deep learning. And in machine learning enables machines to take decisions on their own based on past data. So here we are talking primarily of supervised learning. And it needs only a small amount of data for training, and then works well on low-end systems, so you don't need large machines. And most features need to be identified in advance and manually coded. So basically the feature engineering part is done manually, and the problem is divided into parts and solved individually and then combined. So that is about the machine learning part. In deep learning basically enables machines to take decisions with the help of artificial neural networks. So here in deep learning we use neural nets. So that is the key differentiator between machine learning and deep learning. And usually deep learning involves a large amount of data, and therefore the training also requires, usually the training process requires high-end machines because it needs a lot of computing power. And the machine learning features the feature engineering is done automatically. So the neural networks takes care of doing the feature engineering as well. And in case of deep learning, therefore, it is said that the problem is handled end to end. So this is a quick comparison between machine learning and deep learning in case you have that kind of a question. Then you might get a question around the uses of machine learning or some real life applications of machine learning in modern business. The question may be worded in different ways, but the meaning is how exactly is machine learning used, or actually supervised machine learning. It could be a very specific question around supervised machine learning. So this is like give examples of supervised machine learning, use of supervised machine learning in modern business. So that could be the next question. So there are quite a few examples or quite a few use cases, if you will, for supervised machine learning. The very common one is email spam detection. So you want to train your application or your system to detect between spam and non-spam. So this is a very common business application of supervised machine learning. So how does this work? The way it works is that you obviously have historical data of your emails, and they are categorized as spam and not spam. So that is what is the labeled information. And then you feed this information or all these emails as an input to your model, right? And the model will then get trained to detect which of the emails are to detect which is spam and which is not spam. So that is the training process. And this is supervised machine learning because you have labeled data. You already have emails which are tagged as spam or not spam. And then you use that to train your model, right? So this is one example. Now, there are a few industry-specific applications for supervised machine learning. One of the very common ones is in healthcare diagnostics. In healthcare diagnostics, you have these images and you want to train models to detect whether from a particular image, whether it can find out if the person is sick or not, whether a person has cancer or not. Right? So this is a very good example of supervised machine learning. Here, the way it works is that existing images, it could be X-ray images, it could be MRI or any of these images are available and they are tagged saying that, okay, this X-ray image is defective or the person has an illness or it could be cancer, whichever illness, right? So it is tagged as defective or clear or good image and defective image, something like that. So we come up with a binary, or it could be multi-class as well, saying that this is defective to 10%, this is 25%, and so on. But let's keep it simple. You can give an example of just a binary classification, that would be good enough. So you can say that in healthcare diagnostics, using image, we need to detect whether a person is ill or whether a person is having cancer or not. So here, the way it works is you feed labeled images and you allow the model to learn from that, so that when new image is fed, it will be able to predict whether this person is having that illness or not, having cancer or not, right? So I think this would be a very good example for supervised machine learning in modern business. All right, then we can have a question like, so we've been talking about supervised and unsupervised, and so there can be a question around semi-supervised machine learning. So what is semi-supervised machine learning? Now, semi-supervised learning, as the name suggests, it falls between supervised learning and unsupervised learning, but for all practical purposes, it is considered as a part of supervised learning. And the reason this has come into existence is that in supervised learning, you need labeled data. So all your data for training your model has to be labeled. Now, this is a big problem in many industries or under many situations. Getting the labeled data is not that easy because there's a lot of effort in labeling this data. Let's take an example of the diagnostic images. We can just, let's say, take X-ray images. Now, there are actually millions of X-ray images available all over the world. But the problem is they are not labeled. So their images are there, but whether it is defective or whether it is good, that information is not available along with it, right, in a form that it can be used by a machine, which means that somebody has to take a look at these images, and usually it should be like a doctor, and then say that, okay, yes, this image is clean and this image is cancerous, and so on and so forth. Now, that is a huge effort by itself. So this is where semi-supervised learning comes into play. So what happens is there is a large amount of data. Maybe a part of it is labeled. Then we try some techniques to label the remaining part of the data so that we get completely labeled data, and then we train our model. So I know this is a little long winding explanation, but unfortunately there is no quick and easy definition for semi-supervised machine learning. This is the only way probably to explain this concept. We may have another question as what are unsupervised machine learning techniques? Or what are some of the techniques used for performing unsupervised machine learning? So it can be worded in different ways. So how do we answer this question? So unsupervised learning, you can say that there are two types, clustering and association. And clustering is a technique where similar objects are put together. And there are different ways of finding similar objects. So their characteristics can be measured, and if they have, in most of the characteristics, if they are similar, then they can be put together. This is clustering. Then association, I think the best way to explain association is with an example. In case of association, you try to find out how the items are linked to each other. So for example, if somebody bought maybe a laptop, the person has also purchased a mouse. So this is more in an e-commerce scenario, for example. So you can give this as an example. So people who are buying laptops are also buying a mouse. So that means there is an association between laptops and mouse. Or maybe people who are buying bread are also buying butter. So that is a association that can be created. So this is unsupervised learning, one of the techniques. Okay. All right, then we have very fundamental question. What is the difference between supervised and unsupervised machine learning? So machine learning, these are the two main types of machine learning, supervised and unsupervised. And in case of supervised, and again here, probably the keyword that the person may be wanting to hear is labeled data. Now, very often people say, we have historical data, and if we run it, it is supervised, and if we don't have historical data, yes, but you may have historical data, but if it is not labeled, then you cannot use it for supervised learning. So it's very key to understand that we put in that keyword labeled. Okay, so when we have labeled data for training our model, then we can use supervised learning. And if we do not have labeled data, then we use unsupervised learning. And there are different algorithms available to perform both of these types of trainings. So there can be another question, a little bit more theoretical and conceptual in nature. This is about inductive machine learning and deductive machine learning. So the question can be, what is the difference between inductive machine learning and deductive machine learning, or somewhat in that manner, so that the exact phrase or exact question can vary. They can ask for examples and things like that, but that could be the question. So let's first understand what is inductive and deductive training. Inductive training is induced by somebody, and you can illustrate that with a small example. I think that always helps. So whenever you're doing some explanation, try as much as possible, as I said, to give examples from your work experience or give some analogies, and that will also help a lot in explaining as well, and for the interviewer also to understand. So here we'll take an example, or rather we will use an analogy. So inductive training is when we induce some knowledge or the learning process into a person without the person actually experiencing it. Okay, what can be an example? So we can probably tell the person or show a person a video that fire can burn his finger, or fire can cause damage. So what is happening here? This person has never probably seen a fire or never seen anything getting damaged by fire. But just because he has seen this video, he knows that, okay, fire is dangerous, and if fire can cause damage, right? So this is inductive learning. Compared to that, what is deductive learning? So here you draw conclusion, or the person draws conclusion out of experience. So we will stick to the analogy. So compared to the showing a video, let's assume a person is allowed to play with fire. Right? And then he figures out that if he puts his finger, it's burning, or if he throws something into the fire, it burns. So he is learning through experience. So this is known as deductive learning. Okay, so you can have applications or models that can be trained using inductive learning or deductive learning. All right, I think probably that explanation will be sufficient. The next question is, are KNN and K-means clustering similar to one another, or are they same? Right? Because the letter K is kind of common between them. Okay, so let us take a little while to understand what these two are. One is KNN, another is K-means. KNN stands for K nearest neighbors, and K means, of course, is the clustering mechanism. Now, these two are completely different, except for the letter K being common between them. KNN is completely different. K means clustering is completely different. KNN is a classification process, and therefore it comes under supervised learning, whereas K-means clustering is actually unsupervised. Okay, when you have KNN, when you want to implement KNN, which is basically K nearest neighbors, the value of K is a number. So you can say K is equal to 3. You want to implement KNN with K is equal to 3. So which means that it performs the classification in such a way that, how does it perform the classification? So it will take 3 nearest objects, and that's why it's called nearest neighbor. So basically based on the distance, it will try to find out its nearest objects that are, let's say, 3 of the nearest objects, and then it will check whether the class they belong to which class, right? So if all 3 belong to one particular class, obviously this new object is also classified as that particular class. But it is possible that they may be from 2 or 3 different classes. Okay, so let's say they are from 2 classes, and then if they are from 2 classes, now usually you take a odd number, you assign an odd number to. So if there are 3 of them and 2 of them belong to one class and then 1 belongs to another class, so this new object is assigned to the class to which the 2 of them belong. Now, the value of k is sometimes tricky. Whether should you use 3, should you use 5, should you use 7? That can be tricky because the ultimate classification can also vary. So it's possible that if you're taking k as 3, the object is probably in one particular class, but if you take k is equal to 5, maybe the object will belong to a different class, because when you're taking 3 of them, probably 2 of them belong to class 1 and 1 belong to class 2. Whereas when you take 5 of them, it is possible that only 2 of them belong to class 1 and 3 of them belong to class 2. So which means that this object will belong to class 2, right? So you see that? So the class allocation can vary depending on the value of k. Now, k-means on the other hand is a clustering process, and it is unsupervised, where what it does is the system will basically identify how the objects are, how close the objects are with respect to some of their features. Okay, but the similarity, of course, is the letter k, and in case of k means also we specify its value, and it could be 3 or 5 or 7. There is no technical limit as such, but it can be any number of clusters that you can create. Okay, so based on the value that you provide, the system will create that many clusters of similar objects. So there is a similarity to that extent that k is a number in both the cases, but actually these two are completely different processes. We have what is known as naive Bayes classifier, and people often get confused thinking that naive Bayes is the name of the person who found this classifier or who developed this classifier, which is not 100% true. Bayes is the name of the person, Bayes is the name of the person, but naive is not the name of the person, right? So naive is basically an English word, and that has been added here because of the nature of this particular classifier. Naive Bayes classifier is a probability based classifier, and it makes some assumptions that presence of one feature of a class is not related to the presence of any other feature of maybe other classes, right? So which is not a very strong or not a very accurate assumption, because these features can be related and so on. But even if we go with this assumption, this whole algorithm works very well even with this assumption, and that is the good side of it. But the term comes from there, so that is the explanation that you can give. Then there can be question around reinforcement learning. It can be paraphrased in multiple ways. One could be, can you explain how a system can play a game of chess using reinforcement learning? Or it can be any game. So the best way to explain this is again to talk a little bit about what reinforcement learning is about, and then elaborate on that to explain the process. So first of all, reinforcement learning has an environment and an agent, and the agent is basically performing some actions in order to achieve a certain goal. And these goals can be anything. Either if it is related to game, then the goal could be that you have to score very high, score a high value, high number. Or it could be that your number of lives should be as high as possible. Don't lose lives. So these could be some of them. More advanced examples could be for driving. In the automotive industry, self-driving cars, they actually also make use of reinforcement learning to teach the car how to navigate through the roads and so on and so forth. That is also another example. Now, how does it work? So if the system is basically there is an agent and environment, and every time the agent takes a step or performs a task which is taking it towards the goal, the final goal, let's say to maximize the score or to minimize the number of lives and so on, or minimize the deaths, for example, it is rewarded. And every time it takes a step which goes against that goal, right, contrary or in the reverse direction, it is penalized. Okay, so it is like a carrot and stick system. Now, how do you use this to create a game of chess, or to create a system to play a game of chess? Now, the way this works is, and this could probably go back to this AlphaGo example where AlphaGo defeated a human champion. So the way it works is in reinforcement learning, the system is allowed, for example, if in this case we are talking about chess, so we allow the system to first of all watch playing a game of chess. So it could be with a human being, or it could be the system itself. There are computer games of chess, right? So either this new learning system has to watch that game or watch a human being play the game, because this is reinforcement learning is pretty much all visual. So when you're teaching the system to play a game, the system will not actually go behind the scenes to understand the logic of your software, of this game or anything like that. It is just visually watching the screen and then it learns. Okay, so reinforcement learning to a large extent works on that. So you need to create a mechanism whereby your model will be able to watch somebody playing the game, and then you allow the system also to start playing the game. So it pretty much starts from scratch. Okay, and as it moves forward, it's right at the beginning, the system really knows nothing about the game of chess. Okay, so initially it is a clean slate. It just starts by observing how you're playing. So it will make some random moves and keep losing badly. But then what happens is, over a period of time, so you need to now allow the system, or you need to play with the system, not just 1, 2, 3, 4 or 5 times, but hundreds of times, thousands of times, maybe even hundreds of thousands of times. And that's exactly how AlphaGo has done. It played millions of games between itself and the system, right? So for the game of chess also, you need to do something like that. You need to allow the system to play chess and then learn on its own over a period of repetition. So I think you can probably explain it to this extent, and it should be sufficient. Now, this is another question which is again somewhat similar, but here the size is not coming into picture. So the question is, how will you know which machine learning algorithm to choose for your classification problem? Now, this is not only a classification problem, it could be a regression problem. I would like to generalize this question. So if somebody asks you, how will you choose? How will you know which algorithm to use? The simple answer is, there is no way you can decide exactly saying that this is the algorithm I'm going to use. In a variety of situations, there are some guidelines. Like for example, you will obviously, depending on the problem, you can say whether it is a classification problem or a regression problem. And then in that sense, you are kind of restricting yourself to, if it is a classification problem, you can only apply a classification algorithm, right? To that extent, you can probably, let's say, limit the number of algorithms. But now within the classification algorithms, you have decision trees, you have SVM, you have logistic regression. Is it possible to outright say, yes, so for this particular problem, since you have explained this, now this is the exact algorithm that you can use? That is not possible. Okay, so we have to try out a bunch of algorithms, see which one gives us the best performance and best accuracy, and then decide to go with that particular algorithm. So in machine learning, a lot of it happens through trial and error. There is no real possibility that anybody can, just by looking at the problem or understanding the problem, tell you that, okay, in this particular situation, this is exactly the algorithm that you should use. Then the questions may be around application of machine learning, and this question is specifically around how Amazon is able to recommend other things to buy. So this is around recommendation engine. How does it work? How does the recommendation engine work? So this is basically the question is all about. So the recommendation engine again works based on various inputs that are provided. Obviously, something like Amazon, a website or e-commerce site like Amazon collects a lot of data around the customer behavior, who is purchasing what. And if somebody is buying a particular thing, they're also buying something else. So this kind of association, right? So this is the unsupervised learning we talked about. They use this to associate and link or relate items. And that is one part of it. So they kind of build association between items, saying that somebody buying this is also buying this. That is one part of it. Then they also profile the users, right? Based on their age, their gender, their geographic location. They will do some profiling, and then when somebody is logging in and when somebody is shopping, kind of the mapping of these two things are done. They try to identify, obviously if you have logged in, then they know who you are and your information is available, like for example your age, maybe your gender, and where you're located, what you purchased earlier, right? So all this is taken, and the recommendation engine basically uses all this information and comes up with recommendations for a particular user. So that is how the recommendation engine works. All right, then the question can be something very basic, like when will you go for classification versus regression, right? When do you do classification instead of regression, or when will you use classification instead of regression? Now, yes, so this is basically going back to the understanding of the basics of classification and regression. So classification is used when you have to identify or categorize things into discrete classes. So the best way to respond to this question is to take up some examples and use it. Otherwise, it can become a little tricky. The question may sound very simple, but explaining it can sometimes be very tricky. In case of regression, we use, of course, there will be some keywords that they will be looking for. So just you need to make sure you use those keywords. One is the discrete values, another is the continuous values. So for regression, if we are trying to find some continuous values, you use regression. Whereas if you're trying to find some discrete values, you use classification. And then you need to illustrate. What are some of the examples? So classification is like, let's say there are images and you need to put them into classes like cat, dog, elephant, tiger, something like that. So that is a classification problem. Or it can be, that is a multi-class classification problem. It could be binary classification problem, like for example, whether a customer will buy or he will not buy. That is a classification, binary classification. It can be in the weather forecast area. Now, weather forecast is again combination of regression and classification, because on the one hand, you want to predict whether it's going to rain or not. That's a classification problem. That's a binary classification, right? Whether it's going to rain or not rain. However, you also have to predict what is going to be the temperature tomorrow, right? Now, temperature is a continuous value. You can't answer the temperature in a yes or no kind of a response, right? So what will be the temperature tomorrow? So you need to give a number, which can be like 20 degrees, 30 degrees or whatever. Right? So that is where you use regression. One more example is stock price prediction. So that is where again you will use regression. So these are the various examples. So you need to illustrate with examples and make sure you include those keywords like discrete and continuous. So the next question is more about a little bit of a design related question to understand your concepts and things like that. So it is, how will you design a spam filter? So how do you basically design or develop a spam filter? So I think the main thing here is he is looking at probably understanding your concepts in terms of what is the algorithm you will use, or what is your understanding about difference between classification and regression and things like that, right? And the process, of course, the methodology and the process. So the best way to go about responding to this is we say that, okay, this is a classification problem because we want to find out whether an email is a spam or not spam, so that we can apply the filter accordingly. So first thing is to identify what type of a problem it is. So we have identified that it is a classification. Then the second step may be to find out what kind of algorithm to use. Now, since this is a binary classification problem, logistic regression is a very common algorithm. But however, right, as I said earlier also, we can never say that, okay, for this particular problem, this is exactly the algorithm that we can use. So we can also probably try decision trees or even support vector machines, for example, SVM. So we will kind of list down a few of these algorithms and we will say, okay, we would like to try out these algorithms. And then we go about taking your historical data, which is the labeled data, which are marked. So you will have a bunch of emails, and then you split that into training and test data sets. You use your training data set to train your model or your algorithm that you have used, or rather the model actually. So, and you actually will have three models. Let's say you are trying to test out three algorithms, so you will obviously have three models. So you need to try all three models and test them out as well, see which one gives the best accuracy, and then you decide that you will go with that model. Okay, so training and test will be done, and then you zero in on one particular model, and then you say, okay, this is the model we will use, and then go ahead and implement that or put that in production. So that is the way you design a spam filter. The next question is about random forest. So what is random forest? So this is a very straightforward question. However, the response, you need to be again a little careful. While we all know what is random forest, explaining this can sometimes be tricky. So one thing is, random forest is kind of, in one way, it is an extension of decision trees, because it is basically nothing but you have multiple decision trees, and trees will basically we will use for doing, if it is classification, mostly it is classification, you will use the trees for classification, and then you use voting for finding the final class. So that is the underlyings. But how will you explain this? How will you respond to this? So first thing, obviously, we will say that random forest is one of the algorithms, and the more important thing that you need to, probably the interviewer is waiting to hear, is ensemble learner, right? So this is one type of ensemble learner. What is ensemble learner? Ensemble learner is like a combination of algorithms. So it is a learner which consists of more than one algorithm or more than one maybe models. Okay, so in case of random forest, the algorithm is the same, but instead of using one instance of it, we use multiple instances of it, and we use. So in a way, that is a random forest is an ensemble learner. There are other types of ensemble learners where we have, like, we use different algorithms itself. So you have one maybe logistic regression and a decision tree combined together, and so on and so forth. Or there are other ways, like for example, splitting the data in a certain way, and so on. So that's all about ensemble. We will not go into that. But random forest itself, I think the interviewer will be happy to hear this word ensemble learner. And so then you go and explain how the random forest works. So if the random forest is used for classification, then we use what is known as a voting mechanism. So basically, how does it work? Let's say your random forest consists of 100 trees, okay, and each observation you pass through this forest, and each observation, let's say it is a classification problem, binary classification 0 or 1, and you have 100 trees. Now if 90 trees say that it is a 0 and 10 of the trees say it is a 1, you take the majority. You may take a vote, and since 90 of them are saying 0, you classify this as 0. Then you take the next observation, and so on. So that is the way random forest works for classification. If it is a regression problem, it's somewhat similar, but only thing is, instead of vote, what we will do is, so in regression, remember what happens? You actually calculate a value, right? So for example, you're using regression to predict the temperature, and you have 100 trees, and each tree obviously will probably predict a different value of the temperature. They may be close to each other, but they may not be exactly the same value. So these 100 trees. So how do you now find the actual value, the output for the entire forest, right? So you have outputs of individual trees which are a part of this forest, but then you need to find the final output of the forest itself. So how do you do that? So in case of regression, you take like an average or the mean of all the 100 trees, right? So this is also a way of reducing the error. So maybe if you have only one tree, and if that one tree makes an error, it is basically 100% wrong or 100% right? But if you have, on the other hand, if you have a bunch of trees, you are basically mitigating that error, reducing that error. Okay, so that is the way random forest works. So the next question is, considering the long list of machine learning algorithms, how will you decide on which one to use? So once again, here there is no way to outright say that this is the algorithm that we will use for a given data set. This is a very good question, but then the response has to be like, again, there will not be a one size fits all. So we need to, first of all, you can probably shorten the list in terms of by saying, okay, whether it is a classification problem or it is a regression problem. To that extent, you can probably shorten the list, because you don't have to use all of them. If it is a classification problem, you only can pick from the classification algorithms, right? So for example, if it is a classification, you cannot use linear regression algorithm there. Or if it is a regression problem, you cannot use SVM, or maybe, no, you can use SVM, but maybe a logistic regression, right? So to that extent, you can probably shorten the list, but still you will not be able to 100% decide on saying that this is the exact algorithm that I'm going to use. So the way to go about is, you choose a few algorithms based on what the problem is. You try out your data, you train some models of these algorithms, check which one gives you the lowest error or the highest accuracy, and based on that, you choose that particular algorithm. Okay. All right. Then there can be questions around bias and variance. So the question can be, what is bias and variance in machine learning? So you just need to give out a definition for each of these. For example, bias in machine learning, it occurs when the predicted values are far away from the actual value. So that is a bias. Okay. And whereas they are all the values are probably they are far off, but they are very near to each other though. The predicted values are close to each other, right? While they are far off from the actual value, but they are close to each other. You see the difference? So that is bias. And then the other part is your variance. Now, variance is when the predicted values are all over the place, right? So if the variance is high, that means it may be close to the target, but it is kind of very scattered. So the predicted values are not close to each other, right? In case of bias, the predicted values are close to each other, but they are not close to the target. But here they may be close to the target, but they may not be close to each other. So they are a little bit more scattered. So that is what in case of a variance. Okay, then the next question is about, again, related to bias and variance. What is the trade-off between bias and variance? Yes, I think this is an interesting question because these two are heading in different directions. So for example, if you try to minimize the bias, variance will keep going high. And if you try to minimize the variance, bias will keep going high. And there is no way you can minimize both of them. So you need to have a trade-off saying that, okay, this is the level at which I will have my bias and this is the level at which I will have variance. So the trade-off is that pretty much that you decide what is the level you will tolerate for your bias and what is the level you will tolerate for variance, and a combination of these two in such a way that your final results are not way off. And having a trade-off will ensure that the results are consistent, right? So that is basically the output is consistent, and which means that they are close to each other, and they are also accurate, which that means they are as close to the target as possible, right? So if either of these is high, then one of them will go off the track. Define precision and recall. Now again, here I think it would be best to draw a diagram and take the confusion matrix, and it is very simple. The definition is like a formula. Your precision is true positive by true positive plus false positive, and your recall is true positive by true positive plus false negative. Okay, so that's, you can just show it in a mathematical way. That's pretty much that can be shown. That's the easiest way to define. So the next question can be about decision tree. What is decision tree pruning and why is it? So basically, decision trees are really simple to implement and understand, but one of the drawbacks of decision trees is that it can become highly complicated as it grows, right? And the rules and the conditions can become very complicated, and this can also lead to overfitting, which is basically that during training you will get 100% accuracy, but when you're doing testing you will get a lot of errors. So that is the reason pruning needs to be done. So the purpose or the reason for doing decision tree pruning is to reduce overfitting or to cut down on overfitting. And what is decision tree pruning? It is basically that you reduce the number of branches, because as you may be aware, a tree consists of the root node, and then there are several internal nodes, and then you have the leaf nodes. Now if there are too many of these internal nodes, that is when you face the problem of overfitting, and pruning is the process of reducing those internal nodes. Alright, so the next question can be, what is logistic regression? So basically, logistic regression is one of the techniques used for performing classification, especially binary classification. Now, there is something special about logistic regression, and there are a couple of things you need to be careful about. First of all, the name is a little confusing. It is called logistic regression, but it is used for classification. So this can be sometimes confusing. So you need to probably clarify that to the interviewer if it's really, if it is required. And they can also ask this like a trick question, right? So that is one part. Second thing is, the term logistic has nothing to do with the usual logistics that we talk about, but it is derived from log. So that the mathematical derivation involves log, and therefore the name logistic regression. So what is logistic regression and how is it used? So logistic regression is used for binary classification, and the output of a logistic regression is either a 0 or a 1, and it varies. So it's basically, it calculates a probability between 0 and 1, and we can set a threshold that can vary. Typically it is 0.5. So any value above 0.5 is considered as 1, and if the probability is below 0.5, it is considered as 0. So that is the way we calculate the probability, or the system calculates the probability, and based on the threshold it sets a value of 0 or 1, which is like a binary classification, 0 or 1. Okay, then we have a question around k nearest neighbor algorithm. So explain k nearest neighbor algorithm. So first of all, what is a k nearest neighbor algorithm? This is a classification algorithm. So that is the first thing we need to mention. And we also need to mention that the k is a number. It is an integer. And this is variable, and we can define what the value of k should be. It can be 2, 3, 5, 7, and usually it is an odd number. So that is something we need to mention. Technically it can be even number also, but then typically it would be odd number, and we will see why that is. Okay. So based on that, we need to classify objects. Okay, we need to classify objects. So again, it will be very helpful to draw a diagram. If you're explaining, I think that will be the best way. So draw some diagram like this, and let's say we have 3 clusters or 3 classes existing, and now you want to find for a new item that has come, you want to find out which class this belongs to, right? So you go about, as the name suggests, you go about finding the nearest neighbors, right? The points which are closest to this, and how many of them you will find, that is what is defined by k. Now let's say our initial value of k was 5. Okay? So you will find the 5 nearest data points. So in this case, as it is illustrated, these are the 5 nearest data points. But then all 5 do not belong to the same class or cluster. So there are one belonging to this cluster 1, the second one belonging to this cluster 2, 3 of them belonging to this third cluster. Okay. So how do you decide? That's exactly the reason we should, as much as possible, try to assign an odd number so that it becomes easier to assign this. So in this case, you see that the majority, actually, if there are multiple classes, then you go with the majority. So since 3 of these items belong to this class, we assign, which is basically the, in this case, the green or the tennis or the third cluster, as I was talking about. Right, so we assign it to this third class. So in this case, it is that's how it is decided. Okay, so k nearest neighbors. So first thing is to identify the number of neighbors that are mentioned as k. So in this case, it is k is equal to 5. So we find the 5 nearest points, and then find out of these 5 which class has the maximum number in that. Okay, and then the new data point is assigned to that class. Okay,
and with that, we have come to end of this AI crash course. I hope you found it valuable and entertaining. Please ask any question about the topics covered in this video in the comment section below. Our expert will assist you in addressing your problem. Thank you for watching. Stay safe and keep learning by Simplilearn.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Our programs, and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.